the idea of these trainings is to give you a chance to get some hands-on with a product. We can't have you be building the product here or be doing a lot of stuff with wiring just for liability reasons inside the factory here, but we'll get you as hands-on as you want, and I'll be demonstrating some of the products together. We did build a Sol-Ark training wall to show you. We'll be opening this up, let you look inside. We're going to talk about the wiring. We're going to talk about the new stackable battery that we've come out with. It's designed specifically for the Sol-Ark 15K. And I also want to get you guys acquainted with your reps as well. So Rodolfo is here. Rodolfo is based in Tijuana, just south of San Diego. And then Brian Taylor covers this region as well. And Mark McBride, who are all the people with Sol-Ark in California?
Yeah, so I'm Kyle Bank. I'm the sales manager for essentially Southern California, all the way up to San Luis Obispo. And then Mark McBride is the Northern California rep. So if you do have projects up there, happy to put you in touch as well. Absolutely.
Thank you. Yeah. So we do have one more training we're going to do in Northern California. I figure most of you guys are here in Southern California, and Kyle would be your guide for a rep. So I'm going to go through a presentation focused mostly on introducing you to our new batteries. So you might have installed our SimpliPHI batteries before, the 6.6. You may have installed them. We've only been shipping them for a couple of months. So we're going to start off with an introduction to that battery. That's the stackable battery that you see here. The nice thing about this battery is it's a much faster installation time. It's quite quick to put it together. It's also quite power dense for us. And it's kind of a game changer for us in terms of just the ability to get things done quickly, and the ability to install this up on the wall. It's an outdoor rated battery. You can mount it outside on the wall, you can mount it inside on the wall, you can mount it on the floor. I've got it on a floor base here. I've got the two different base installation options here. And then the nice thing about the battery is the communications, the power, the balancing, all of that is done through a rapid stack connector where it's just you stack the battery, all the wiring is done. So the only wiring you have to do is kind of the home runs from the wiring bay up here, both the communications and the power cabling into the Sol-Ark inverter. And so those home runs, the Sol-Ark 15K has dual inputs, so we do recommend using dual battery cables coming out of the 6.6 stacks. And then the communications, we have closed loop communications integration with Sol-Ark, and so much of the programming, the commissioning is already done for you, right? So I've done a number of these installs with installers in my area. The battery goes up really fast. So did a wall mount of this a few weeks ago, maybe 3 weeks ago now. It took 30 minutes to get the battery assembled. Probably another hour to just do the wiring just because of pulling the cable and running. I ran this with flex here, or seal type flex here on the side. The reason I did that is just at the time I was building this training wall, somebody went in and bought all the LRs, so I couldn't get EMT stuff to do it with. So that's why I'm doing it with flex. Probably a little easier if you do use a couple of LRs here and come down with EMT, because this was a bit tight. But you do meet your 40% rule with your dual cables, etc. So we'll get into all of that. We'll talk about the wiring. We'll talk about how to wire up the Sol-Ark 15K. But as we get started here, I would like you to have a chance to just let me know, or you installers. We had some homeowners show up to the last event we did. So if you don't mind, I'm going to go around the room and just ask you your name and kind of what you do.
What outdoor certifications for the batteries are there?
Yeah, so in terms of certifications, I'll go through some of them when we get to slides. It's IP65 rated once it's all together. So that means dust protection, water protection, etc. In terms of the UL certifications, I have slides on that I'm going to go through. And then the Sol-Ark as well. The Sol-Ark is outdoor rated, same kind of ratings. Everything's stainless steel on this. All the hardware on the battery, etc. is stainless steel. I'll be showing you the wall brackets here in a minute. if you are installing outdoors and you are using a wiring trough like this, you'll want to make sure that you are using the appropriate hubs, etc., to prevent water intrusion. I would say that, if there's one thing I'd like to change on this, it's how to do the conduit on the wiring bay here. And it's fine, but it can be a little bit tricky to get both covers to work. So there's a vanity cover. The engineering team says, well, just don't use the vanity cover. You don't have to put it on. And that's the little cover on the side here. You don't need to include that, but I like to include it just because I like the looks. But that does make it a little more challenging. So the actual seal for the battery for your conduit coming in is on, there's two vertical plates, and it's on the inner one. You don't have to install the outer one. But if you do, it is a little bit more punchy. But otherwise, it's fairly easy to install, and most people who install outside install it up in the air. So on the wall, because you don't always have a level surface to go to that's 90 degrees to your wall. So this is what the wall mount bracket looks like, and I'll share with you what the whole looks like. But let me talk through the training wall to get us oriented. Okay, on the DC side here, we've got the battery. These batteries are 48 volts. They're low voltage, which means reduced regulation, a bit more safety in terms of shock hazard at 48 volts is very unlikely to cause death, right? So a 48 volt shock, yeah, it'll hurt a little bit, but it's not going to kill somebody. And there are less regulations from the NEC around 48 volt batteries. So this is a 48 volt battery stack. The batteries are all in parallel. You can have just a single stack of batteries as opposed to a triple stack. So this is 20 kilowatt hours of storage that's here. They come in 6.65 increments, so it's just under a third of 20 kilowatt hours, and that's the limit from NFPA 855 for stack. And then we're running through, we're bringing the DC into the Sol-Ark, and so that DC from the battery comes in here. We also have communication coming out of the battery and going into the Sol-Ark, and that's on that blue dongle that you can see here. So that's all the DC side. Then on the AC side, what I've got right now, this red bulb that's up here indicates the grid. So John has wired 240 split phase for me. And so when I pull this, it's like a grid going out, and you can see the red light here on the display wall go out. So there's no grid coming in. You can see the meter is dead. The Sol-Ark acts as your interrupt, right? And so it's your micro disconnect occurs inside the Sol-Ark. It's a little bit different than transfer switches. You probably know that, you may know that, but what's happening inside there is really relays that are reacting very quickly. So there's 200 amp pass through from the grid through the Sol-Ark. And so we're doing that with 3-aught cabling. So this is my service entrance. So this is to represent here in California the service entrance with 200 amp service, and that's wired in. And so I've got my utility connection coming through here and coming up into the right side of the inverter. So that's a 200 amp connection coming in. So my utility connection is this. All of that power with the Sol-Ark 15K passes through the inverter relays and passes out to the loads. So this is my load disconnect here. So if I pull this, I've killed the loads for my load panel. So we come in from the utility into the inverter, we come out of the inverter and into the loads, right? So my loads panel is here. I only have a single 15 amp, 20 amp breaker here. Just because I don't have a lot of room on my wall to put a bunch of different loads in. So I've got just a single connection here. But this is to represent what it would look like on a real house, right? It is 200 amp equipment. You would pass that 200 amp through the Sol-Ark, and then you would have a full loads panel somewhere on the house. And so that is on the AC side. Then we have some communications. So we also have communications from this battery into the Briggs Stratton gateway, which is here. So that's the other part of this, is the communications part. And then Sol-Ark on this side, there's a Wi-Fi dongle here for the Sol-Ark, and it'll send its communications out to the My Sol-Ark app, so you can view things there. So you can view with the Energy Track Gateway, you get an individual view of each battery module. You can install up to 18 of these 6.6 modules for a single large installation. And so you can do bigger systems, and that way, you know, if you ever have an issue with one of the batteries, our tech support can see the communication coming from the computer that's inside each battery. So each battery itself has a BMS computer inside it, and that computer is communicating with the hub, the controller on the top, and all that information gets sent to the gateway, and then we send it to the cloud. Okay? This is an overview of the battery of this training wall. Anybody know what these are? Yeah, these are our CTs, so that's how we monitor the power that is coming in from the grid. You might think you don't need them because the 15K is seeing everything that's coming in from the grid, but Sol-Ark lets us know that the telemetry is a little bit more accurate if you include the CTs as well, so you get a little bit more responsiveness. These come with the Sol-Ark, so the CTs come with the Sol-Ark when you buy the Sol-Ark. Make sure to install them. One other thing to point out, and I'll go into more detail on this stuff later, is that there are some round donut-shaped toroids that come with the Sol-Ark. Those are to go over your battery cable, and that's to prevent noise pickup from the battery cables coming into the Sol-Ark. So you want to make sure to pass both your battery cables through both of those toroids. So don't just throw them out or set them aside. Don't let your installers lose them when they're doing these installs. And same with the CTs, make sure to install them. I've had plenty of installers not install the CTs or not install the toroids, just thinking they were specialty items, but you use them for each install. So let's jump into more information about the battery.
And just real quick on the capacity, I want to be real clear. That's 120 kilowatt hours on a single site, right? So
Right.
we've got you covered for what, probably 95% of your installs. For those that are even need larger capacities, we do have other solutions for you.
Yeah, and that limitations, we do get asked, you know, why are we limited on the number of stacks? That is a software limitation right now that could change in the future. So, you know, we're thinking that the majority of installs, you know, most customers are choosing to go with 1 or 2 stacks of batteries. I've got 4 stacks of batteries in my van that I'm driving back to an installer in my town who's going to do one soon. But that's a pretty big system. 80 kilowatt hour system is a pretty large system. I had a 13 kilowatt hour system on my home, and it would back my home up for 24 hours. So going all the way up to 120, you get a long amount of backup from that. Especially in California, and especially near the coast where people aren't using air conditioning quite as much. But certainly they want to use that. And we'll talk about options for, I guess this is not working for me. Give me just a second. See if
And also to be clear on the other side of the scale, and Nathan will probably get to it, but we can also just start with a single battery, right? So for those that want to start cheap, right? You maybe don't have the space or budget, this is a great solution. Just the controller, a single 6.6 Sol-Ark inverter, and the energy track cable. We only need 1 energy track per site. Right? We need 1 controller for every 3 stack.
I got a question.
Yeah.
That gateway that you have over there, does it come with that gray box around it?
It does. Yeah. Yes, it does.
You know why I asked.
I probably should. Help me out.
Well, I'm assuming it has a cover that looks at water type.
Yeah, it has a
Yeah,
cover.
yeah, of course. Yeah, yes.
No, well,
It is a
not
NEVA 3R
everybody
enclosure.
makes it for their gateways to.
Mhm.
Yeah, I've got all the covers
No,
off right
it's
now.
good question.
But yeah, this does get covered up. I've got the Ethernet cable I'm running in here right now, just because the Wi-Fi system's not great here. That's on there.
Do you prefer to have Ethernet versus what is each?
Oh, this is one of these cheap ones where you have to turn it on. It's a power
Yes, we
switch.
do prefer Ethernet.
Right.
We prefer Ethernet just because customers change their Wi-Fi. Wi-Fi can come in and go out. I don't know if Sol-Ark has a preference, but we get less phone calls from tech support, you know, when you're using Ethernet.
So when you have an outage and your communications go out,
When you have an outage and you have this, your communications won't go out. So we always recommend to back up even on small systems, we recommend backing up your communications.
Do you have a momentary shutdown? So
Nope.
that means it's not even a soft brownout, it just stays on.
It just stays on. Yeah, well, yes, exactly. So I'm going to turn the grid back on. So his question was, hey, does the communication go out? You know, does the internet connection go off in a grid down situation? And the answer is, I think it's an 8 millisecond transfer time for the Sol-Ark, right? So 8 thousandths of a second. So it's very fast. And essentially you have an almost an unlimited or uninterrupted power supply. I can't use those exact words because for medical reasons, for medical equipment, it's a bit different. But watch the green light there. So I want to try to answer his question. Go ahead.
Also, the gateway is powered off of 48 volt from the battery, not a 120 volt load. So as long as your modem is still powered up on your backed up loads and internet service hasn't gone out, then you're going to maintain your connection.
So
Yep.
you get what is called a data hiccup,
Sorry.
but it doesn't go out.
Correct.
Is there some
And you may not
capability on
even
our modem?
experience it
Not
because
yet.
it's
No, we
8
don't have
millisecond
it on
transfer
this
of grid
particular
to
modem.
battery. So you may not experience an outage at all.
This particular gateway, we're talking about adding it to next gen.
That's why we powered it off the battery instead of an AC plug.
So let me explain his, so what you heard there was a click. And what had happened is I turned the utility connection back on, but it takes the Sol-Ark, it's settable, but it takes the Sol-Ark 100 seconds to qualify that signal, make sure that it's gonna stay on before it starts passing it through. So while this was off and switching back on, the batteries were supplying the power. Let me point something else out because it's probably going to be charged up fully, but this battery is blinking. When one of these indicator lights on the fuel gauge is blinking, that indicates that the battery is in a state of charge. So right now the battery is charging up. The way I have it set is just for backup power. So the battery does charge off grid. I don't have any solar coming into this obviously, but his question was, does the house lose internet connection when the utility power goes off? I said, well, if you have your internet equipment backed up from the battery, then you're not going to lose connection, not even that momentary connection. So watch the green light on the bottom. I'm going to turn utility off, it's the red light on the top. Watch the green light on the bottom, see if you can see it flicker or do anything. It's just a very quick flicker, right? So that's normally not enough time, especially when you've got a modem that's got a DC power supply to it for the capacitors and in that power supply to even drop enough to make that modem lose connection. So the majority of the time, you're not going to have any problem.
So your modem doesn't lose, well, you don't lose network capability.
Yep, you don't lose network
You're still
capability.
at the mercy of whatever
You-
caused the outage
Yes.
with your.
Yes, you are at the mercy of your internet provider. All right, so I was troubleshooting and taking the batteries out and putting them back into this thing before. I just bought it yesterday, but I realized there was an on-off switch on the side, so I think it's going to work now, and it does. Okay, so we're going to, in this training, I'm going to, the first training, we've got two presentations for you. The first training, I'm going to just talk to you about the batteries, the capabilities, sizing it, a little bit about marketing it, etc. We're going to start off by defining an energy storage system. I assume that most of you know what an energy storage system is. You are in the business, you are selling them. But just a brief overview and talk about the parts. And then we're going to talk about battery backup, the differences between backing up whole home versus backing up maybe a critical loads or a backed up loads panel in the house. So there are many people that for financial reasons choose to just back up a portion of the house. They don't need to back up maybe their water heater or their pool pump or well pump, those kind of things, but they do want to back up the communication, the lights in the house, etc. So there are differences between those. And so we're going to talk about different options for battery backup. We have some packages that are out there that try to guide the homeowner into how much backup time they're going to get. And so I'll present those to you. We'll talk about recommendations. I won't get into code a lot here, but we will talk about where you should be putting batteries, where you can put batteries according to NFPA 855, which are the regulations. The National Fire Protection Association has developed regulations for where you should put batteries. There are different requirements for instance, if you're putting them in the back of a garage where a car could drive in and run into them, you should be putting up parking ballards. there are regulations if you're installing batteries outside on the home, how close to the windows you're supposed to be, how close to the door you're supposed to be. So I'll talk briefly about them, but we won't go into a lot of detail on them. If you're interested in that, we have a codes talk coming up, I think in 2 weeks. It's a webinar, and so you could register for that. And if you do register, we send you a video. You can watch it on your own time if you want. So I think Sol-Ark might join us for that one. I think John Cromer and Daniel, my colleague, will be leading that. And then we'll talk about the specs of the 6.6 batteries, and then we'll talk about selling points for battery-based systems. And then the second half of the day, we're going to get into the connections on the Sol-Ark and how to actually install this system. I will talk a little bit about installing here. The outline is here. We're going to talk about the battery backup systems, etc. I will talk about the how to stock this if you're interested. If you are a Briggs Stratton dealer, Brian can talk to you about how to stock this equipment as well. One of the things about pairing with Sol-Ark that I really like, that I'm really happy about, is the fact that you're dealing with two American-based companies, right? You have a Texas-based company in Sol-Ark. You've got U.S.-based tech support, and the same with SimpliPHI Briggs Stratton here. You know, we're here. We're shipping here from California. They're shipping out of Texas. Our tech support is all U.S.-based, and we're here to honor our warranty. Briggs Stratton's been around for 115 years. It's a household name in the U.S. Sol-Ark has been around since 2013, I think, and they have a great reputation. And so you're dealing with U.S.-based companies, which is, I think, an advantage. So, get an overview just to start out. And this, we're presenting just what that Sol-Ark is. That Sol-Ark, the inverter, is the center of your battery backup system. And so it manages power coming in from different places. It manages power coming in from batteries, but it could also manage power coming in from solar, right? You can manage power coming in from micro wind projects. So we don't see a lot of that. We were asking John Cromer from Sol-Ark if he sees much wind coming in. There's still plenty of installers that are doing wind in specific locations in the U.S. So the Sol-Ark inverter can do that. It can take in solar, utility power, generator power, AC coupled solar, which means microinverters or string inverters bringing in through the Sol-Ark. And so there's a lot of flexibility with this inverter, right? It has rapid shutdown capability built into it so that you can use your rapid shutdowns, different brands, etc. And so we can talk about those. So at the core of your energy storage system is an inverter, right? And the Briggs Stratton prefers that Sol-Ark inverter just because of how flexible it is and how good of a product it is. At the core of your battery backup system, obviously, is a battery, right? And the battery that we're using is LFP chemistry. I'm going to get into that. It's longest lasting. So 10 years ago, battery backup was just starting to emerge as a viable option, right? Batteries 20 years ago, 15 years ago, were most often deep cycle lead acid, and you'd get 5 years out of your battery bank, and it was questionable as to whether or not it was a good investment, right? Now we're looking at 5,000-6,000 cycles out of a battery, 20-year lifetime. It makes a lot more sense than having to install a battery system that lasts for 5 years like it used to be. Now you get a 10-year warranty, unlimited cycles out of this battery. These batteries, we give a 15-year warranty, unlimited number of cycles out of them. And so you're really getting a battery that's lasting to pay itself off. All right. So let's jump into the difference between partial home backup with batteries and whole home backup with batteries. So that's a major choice for a consumer that's deciding on battery backup for their home. So it used to be that when you would install a battery system, you would only back up some of the loads in the house. Inverters traditionally have been fairly small, and Sol-Ark has really changed the game. I think you guys came out with this 2019 with this inverter having 200 amp pass-through. Because what that means is that now all of the power from the grid can pass through the inverter, and the entire loads, all of the loads of the house, the main panel of the house, is on that inverter, right? Previously, you would have to, or with smaller inverters, right? You would pass some of the panels. You take some of the loads. You would take some of the loads out of the main panel, put them in a sub panel, and that sub panel would be backed up. So in a grid down situation, the Sol-Ark isolates itself from the grid, so it's not sending any power back onto the lines that could hurt a lineman, right? And then it keeps alive this critical loads panel. So with the 8K, the 12K Sol-Ark, you have 63 amps of passive. It's not quite enough to back up a whole home unless you've got a very small home or small amount of loads on it. And so you would back up part of the home. And so we'll show you some options for that. And then for the whole home backup, you've got all 200 amps of ability through a single Sol-Ark. If you need more than that, the install that's happening in my area has I guess 400 amps of service. He's got another one where the guy has 600 amps of service, and so you can stack multiple Sol-Arks, you can parallel multiple Sol-Arks to get more pass-through. So if you have 400 amps of service because you're doing a very, very large home, just parallel 2 Sol-Ark 15Ks and you've got it. So, why would somebody choose a battery backup system versus a generator, for instance? And there are a lot of reasons why batteries will make more sense than generators. I'm not going to go through all of them, but I will go through some of them with you because it is important to understand who's buying these systems that you're installing and selling. One of them might be, if you're getting frequent outages, but they don't last very long, a battery system is a great option for that because you have uninterrupted power. So unlike a generator, when you lose utility power, the generator takes a little while to start up, right? So the generator starts up and then you have to wait for at least 60 seconds for the generator signal to qualify, and then it switches over. And to your point, the internet connection has gone down, the clocks in the house need reset, right? You lose power momentarily. Well, with an inverter battery-based system, you don't lose power, and for short durations, you can back it up relatively cheaply. I lived in West Africa for a while, and the utility would cycle our electricity off every couple of hours. Well, not every couple of hours, a couple of times a day, so maybe 6, 8, 10 hours you have power, and then they do called rolling blackouts. They just didn't have enough capacity to meet the demand. This would have been a nice system to have over there, right? So you still have your internet, all those things when the power goes out. So short duration outages, batteries are a great choice. If you have noise ordinances, if you're in an HOA that doesn't allow generators, well, obviously you've got to choose a backup system that's quiet, that'll work. And batteries are easier to install than generators in that permitting is easier for one, but noise ordinances, you don't have problems with that, and then exhaust fumes, right? They're the challenges of carbon monoxide poisoning, etc. if you put generators in the wrong spot. Customer might not have access to natural gas. They might not want a big propane tank in their yard, so that's a reason that a battery system would be better. Maybe the customer wants to integrate solar, maybe in the future, maybe now, right? So installing solar power, you need to use a battery to really take advantage of now that we're in NEM 3.0. Used to be you could use the grid as your battery, right? So it used to be that under NEM 2.0, your solar system produces extra energy and you send those number of kilowatt hours to the grid. And then you buy a certain number of kilowatt hours from the grid, and at the end of the year you do what it's called a true up. And if you've sent more kilowatt hours to them than you've pulled away from them, then they would pay you for those. If you pulled more from them, then you would owe them some money. But you can't do that anymore under NEM 3.0. And so NEM 3.0 basically makes solar not very valuable unless you're either consuming all your solar during the day or you have a battery system to save that solar up during the day, that excess solar up during the day, and then discharge during the nighttime when you need to power your loads. So NEM 3.0 does make a battery-based backup system quite valuable. Then the customer can, the nice thing about the battery system is the customer can expand in the future. So within a few years, they want to add more batteries to the system, they can add more battery backup. And that's nice, it's flexible, right? You install one generator, you can't add another one in parallel to 2 generators, right? So a big difference there. You can always add another inverter, you can add more batteries. We don't recommend adding batteries if you've waited a number of years. We don't want to pair new batteries with old batteries, but if the batteries are only a couple of years old, yeah, you can absolutely add more batteries to it.
I have a question.
Yes.
When you say you can add more batteries, are you allowed to do that without a new interconnection agreement?
That I don't know the answer to, and I'm not sure.
What's the question?
Do you have to change? You have to get a new interconnection agreement if you change the battery capacity of your system.
Yeah. Right.
You're supposed to update your interconnection agreement.
So then you go through the same process that you went through when you.
I will defer to the installers here. So what?
I believe it doesn't affect your NEM status at least, but I think you do have to file a interconnection agreement, but at least you'll stay on that.
Is
net
updating
metering rate.
is updating that agreement as troublesome as getting it the first time? Does it take a long duration?
No.
Okay.
It's the same process. You go into PowerPort and just update the information. But yeah, technically, anytime you increase the size of the generator, you have to notify the utility.
Okay. So if you add more solar, if you add more batteries, you should add. You should notify.
And the self-generation piece is what triggers any upgrade. It's 10% up and down, depending on the kind of meter. Yeah.
Is
Thank
it
you.
add more batteries or just add more generator or inverter? You know?
That's the same thing from the utility perspective.
But the
yeah,
battery
that's-
capacity, they also want to see it. In
That's a
the-
generator.
Yeah.
It's not a battery, it's a generator for the utility. Yeah, so anytime you increase,
I was thinking maybe they just consider the inverter the actual kind of power generator, the battery tank.
yeah,
would be-
but
they'd be indifferent.
the battery size is the generator, because that's the stored capacity.
Okay. So thanks. And these questions I always learn during these presentations, so I appreciate the question. So again, I didn't want to spend a lot of time on this. Nice thing about battery systems is you can install them indoors. Doesn't mean you should put it in a living room, right? It can't be in a habitable space, but you can put it in a garage, you can put it in a utility closet. You can put them in a basement. We don't have a lot of them out here, but on the East Coast, everybody's got a basement and they want to put things in the basement. There are more regulations about putting battery systems in basements, but you can do up to 40 kilowatt hours in the basement. Yes?
We do a lot of triple redundancy type systems and battery backup. You're gonna, and generator backup as well. Are you going to be discussing how this ties in with the generator?
Yep, the second half of the training. This is more of an introduction on batteries, and I want to move a little bit faster than doing it. So you can install indoors. Nice thing about battery system, no maintenance, you don't have to change the oil. You don't have to change the starter battery, that kind of thing. And then the customer might only want to back up critical loads. A small system you can get in at pretty low prices, Sol-Ark 8K, smaller systems. Why a Sol-Ark inverter, right? And this is me, not him talking. I think that, I mentioned one, Texas-based company. Two, they're very dependable. They have a great reputation out in the market. It's a next generation transfer switch, and it advantages all sorts of different power that you can bring into it. You can do it for load, you can do things like load shedding with it. You can bring in, like I said, wind, solar, generator. It's great for our generators, bringing generators in the Sol-Ark 15K is great at. You also have seamless backup, which what I mean by that is the lights don't go out, the clocks don't reset. When you have this battery-based system with Sol-Ark, some systems are faster, slower. Sol-Ark is very fast. So we're partnering with Sol-Ark because I think we believe it's the best product that's on the market. It's not the cheapest, but we believe it's the best inverter on the market. And the fact that it's the biggest inverter on the market. It allows you to bring 200 amps through. It allows you to do 12K out of the batteries. 15K when you add some solar to that, and it's what we think is the best inverter design. So I'll let Kyle talk a little bit about. Do you want to talk about the history of Sol-Ark a little bit?
Sure, yeah, maybe briefly. So Sol-Ark, we've been around since 2013. We're really the first kind of hybrid inverters on the market that really kind of stepped up. And our CEO, a lot of veterans, started the company, and yeah, we've been growing, very very quickly, a couple times per year, And now with NEM 3.0, Sol-Ark is one of the, really one of the top options, especially in California and the United States. So, yeah, things are going well.
Yeah, and I think I want to say, if you're doing this is mostly a training on residential, but Sol-Ark has a 30K and a 60K inverter. So if you've got 208 three-phase, or if you have 480 three-phase, and you want to do higher voltage batteries, we make a high voltage battery that pairs with them. Sol-Ark makes their own high voltage battery as well, and I'll get into that just a little bit as we talk through the inverters. So often companies will do both residential and commercial, and we have options for you.
And it's good in Southern California. I've been working with a lot of 208 volt residential or 480 volt residential. So those are Sol-Ark makes some good products for kind of those special situations that you might run into.
Okay, so I'm going to go through an introduction on the batteries and just point out the components of the battery. So each battery has a controller that has to sit at the top of it. So it doesn't matter if it's a single module or a double stack or a triple stack. You do have to buy one controller, and that controller is what coordinates and makes sure that the batteries stay balanced, etc. It manages the communication that's coming in and talks to the computer inside each of the batteries. So each battery has what's called a BMS inside of it, a battery management system, and the controller talks to the individual BMS units in the batteries. You need battery modules, obviously, for your battery stack, so all the storage is in these modules. You can do up to 3 per stack, up to 6 stacks, so for a total of 18. And then you have to choose a type of base. So we've got a wall mount base that's shown here. You could also choose a floor mount base. What's here on my system is a floor mount base, so that the load of the inverter, or the load of the batteries, is on the base, and that's sitting on the floor. So if you want it up in the air, you need a wall mount base. So these are your two options. So this is the floor base. It's not just a plate. There is some communication that's here. So all of the battery modules themselves have these press fit connectors that carry the power and the balancing through them. They also have these pins that carry the communication. In the base itself, they're just 4 pins, and those contain what are called terminating resistors. And so it lets the controller know and the battery know that, hey, this is the end of the line, this is the last battery here. So you want to make sure that you don't damage those as you're doing your install. And then the wall base, instead of transferring the load of the batteries, that battery bank is 450 pounds, right? It's maybe a little less than that, 135 pounds per module. So I think I got that a little high. It's probably closer to 400 pounds. But then this is the wall base. This wall base is pretty hefty. It's probably 30 pounds or something. But you would then secure this to the studs. And so if you are installing with a wall base, it's important that you first locate your studs. Right? You want to make sure you know where your studs are so that you appropriately distribute the weight between those studs. And it's got space for 24-inch on center, 16-inch on center, and 12-inch on center alignment holes. And you would run lag screws through this. So when you are connecting this to the wall, make sure you know where those studs are. And then if you are using long lag screws, I encourage you to make sure to at least scan it with your stud finder. Make sure, so the stud finders should have an AC detector on them. Most of even the cheap ones will have an AC detector. So just make sure, because depending on where you're running that base, running the leg screws in, there might be wiring that's run through the studs, right? So it does
water pipes.
And water pipes as well, right? And there is equipment to scan for those, but just keep those things in mind as you're doing your installation. Yes?
For your, I guess for both, do you have other means of connecting the batteries so they're not falling over?
Yeah, so you don't see it on this one. I'm about to show you this on another slide, but good question. So we'll get to that. So this is what secures the batteries to the wall. So all of this is hidden. You don't see it here with the battery that's on the wall. It looks like it's just floating. But this is the racking that keeps that battery attached to the top of the wall as well. And so these, both the battery above and below, secure with what we call shoulder screws through the tabs that are on here. And this prevents the battery from tipping over. The majority of the weight is still on the wall bracket, the base itself. But this makes sure that it stays in place on the wall. and we need this, right? We've gone through category 9 earthquake testing with this battery, right? And I will say that, you know, one of the things Sol-Ark points out when they talk about our battery is, hey, it looks like a US-based design, right? It's solid. There are battery companies out there that build a big battery like this. They just connect the modules to each other, and they have 2 little L brackets at the top that are probably not even going to align with your studs, right? And that's supposed to prevent the battery from tipping off. Well, we're in an earthquake zone, so yes, we've built a pretty robust system for attaching this battery to the wall. It's important to us, and safety has been a big thing for SimpliPHI batteries. Always been known as a safe battery. Yes.
That battery extra mounting kit that you're holding slides into the center of that wall mounted part.
Exactly, yeah, so for this mounts right there on the wall mount part, and then on the floor mount part there's a spacer that you sit this on. It's just a plastic spacer you sit this on that gets the alignment for you. So in the wall mount part you do bolt this, the whole thing together, and I recommend, you know, assembling everything, then putting it on the wall, and then you build the batteries onto this. And so this system is behind this battery, which is why I asked John to bring me another one just so you guys could see it. But I'll show you some pictures, and then there's a video that I'll show you of John and I putting together a training wall.
Nathan, I was just curious, so fire codes and HJ restrictions around, you know, Southern California, are you seeing more wall-based or floor-based systems?
So there aren't that many wall-based options that are out there. I think that you'd have to ask Brian what's more popular for us. We only got a couple of months worth of data on what's being purchased, but
I see more wall bases, but I mean, we'll know more as the sample size gets a little bigger.
yeah.
Yep.
Nice.
Yeah, in a garage, I think people don't care as much, but I personally just like the idea of having it off the ground so I can sweep the floor. You know, I like, and I will say that there aren't a whole lot of options for wall mount batteries to compete with us. So, okay, so those are the parts. The energy track gateway. That's where the controller communicates through the internet. So this should be an Ethernet connection or a Wi-Fi connection. We don't have a cellular yet. Okay. Hopefully that's coming soon. So point out some features of the battery. So first, in the bottom left-hand corner, each of the battery modules that are here, you see that light on it. That solid green light means that the battery module is on and that it's healthy. Everything's going well. If the battery is in a state, maybe a firmware update, each of the module lights would be blinking, so that green light would be blinking. There is a fuel gauge at the top of the battery. Just point that out. So this is a fuel gauge. It's saying it's 100% full right now. I plugged it in last night, so it's been charging up. And then on the power button itself, there's a status indicator light on that as well. When the battery is in a state of charge, let's suppose it was 50% and charging, you would see the first 2 lights on, and then you would see the third light blinking, and that just means, hey, I'm at 50% or greater, and I'm charging up towards 75. It's nice having a little indicator on there. Not all of our, if you've installed some of our other batteries, you can see it through your app on your phone, but you don't necessarily see it when you're standing at the battery. So it was one of the things that we wanted to add for this newer design. Okay, so the connections themselves, so I don't have an empty shell to show you, but there is that rapid stack connector that you see on this. There is one with a few more pins for more communication on the top and the bottom of every battery. And you simply lift this battery up. There are some handles on it. You lift it up, you set it in place, and all that communication, all the balancing equipment is done through that. It's fairly quick to do a build. And so that's what we're calling the rapid stack battery connector. There's more than just 2 because you're not just having a common bus. We need to make sure that the load on the batteries is distributed uniformly between the bottom battery and the top battery, right? So it's more sophisticated than just having 2 battery cables running along. And there is no hidden cables. There are other companies that have stacking batteries, supposedly stacking batteries, but if you take the cover plates off the side, they have just wires running down the side, right? All of this is done through our stacking connector that's being shown there. So kind of marketing photo there, you don't see the racking behind it, but just showing you kind of how it goes together. That was shown with a floor mount option right there. The base options, we've already talked about those. I will say that this, the connection here, don't use 1.5 inches. So if you're an installer and you're deciding which size EMT to use, can you use 1.5 inches? Barely, but technically for the 40% rule, you should be including the insulation size, and I think at 1.5 inches, we're right at the limit. John might know, it might just barely go, but I will say that if you're pulling dual sets of cables through 1.5 inch conduit, it's going to be tight. It's going to be harder to do. So use 2-inch conduit on the side. I think this is a 3/4 here from marketing, not to pick on them too much. You do a great job. So the features to point out about this, the battery. So we're using LFP battery. Lithium ions typically do not charge below 32 degrees Fahrenheit. Well, we've got a little bit more advanced electrolyte in this battery, and this battery can charge all the way down to 14 Fahrenheit, so it's another advantage of these batteries. Cold temperature, it's early morning, it's cold, but the sun is out. Well, your batteries start charging earlier with our battery versus some of the competition that doesn't start charging until 32, right? I believe, I'm not sure what the I think the Powerwall might not charge until 32. There are some other batteries in the market that don't start charging until 32. So if you're doing an altitude installation in cold weather as a consideration, these batteries will get started charging a bit earlier. Also pointing out that we've got a pretty fast charge and discharge rate. The battery modules themselves are capable of 1C, which means capable of discharging in 1 hour. So that's what 1C means, the full capacity of the battery per hour. 0.75C, we're looking at 4,500 cycles. That's an hour and 20-minute charge cycle, discharge cycle. So we're running quite quickly. We're still looking at 4,500 cycles, 365 cycles. If you do one once daily, so you get an idea of how many cycles you're expecting. And we actually don't expect customers charging, discharging their batteries in an hour and 20 minutes, right? Most people are expecting to charge, discharge the batteries slower. Well, slower charges and discharges is much easier on the battery, so we're expecting them to get more than the number of cycles we get in our kind of engineering lab testing, right? And so
Nathan,
if we slow it down a little bit, so they're 2-hour charge, 2-hour discharge, we're looking at 6,000 cycles. Yes?
and just to give you an idea, I think like isn't the Powerwall 3 the charge rate, isn't that still 5 kilowatt hours?
Yeah,
Or 5 kilowatts?
5 kilowatts,
So we're looking
yeah.
at about 2.7, roughly 3 hours to charge that battery.
Right, so we can charge a lot faster than the Powerwall 3. Yeah, discharge, the Powerwall 3 is there with us, but on the charge side, we can charge faster. And if you've got a generator integrated in your system, and you want to charge your battery quickly so you can turn the generator off and save your fuel, that charge rate matters, right? You got the generator going and it's cold and it's nighttime, the temperature matters. So those are some of the features to point out about the batteries here. So we're looking at 15, 20 years worth of cycles here. We also are using LFP chemistry. So there's multiple types of lithium-ion battery chemistries. There's LFP is lithium iron phosphate. They mostly vary in the cathode, what the material is to collect the electrons when the battery is discharging. There are other companies out there still using NMC. So if you see battery fires with a car accident where the battery got crushed and it starts on fire, generally you're looking at NMC battery fires. You're not looking at LFP. LFP is a much safer chemistry that SimpliPHI has been using since 2010 when we started Rodolfo. It's just a much safer battery chemistry. So even if you use our competitors, I don't encourage you to use anything other than LFP battery chemistry. It's just a lot safer for a house. So do keep that in mind, and it's also the most number of cycles, right? So you get more cycles out of it. And really, about 1.5 years ago, Tesla and Rivian have switched to doing more than half of their cars now with LFP battery chemistry. Just because it's a little heavier, and that does matter for transportation for cars, it doesn't matter much for a house. It's a little heavier, but you get more cycles, you get more life out of it, and so LFP has kind of been the leading chemistry. We felt like we've kind of pioneered LFP chemistry when everybody else was using NMC. So we did talk about this already. we can do a single stack. You can get 6.6 kilowatts of power out of a single stack, so it's not quite enough to fully take advantage of an 8K Sol-Ark. But for a price-conscious customer, you can get 6.6 kilowatts of power. That's more than enough for my home. I never used more than that. But you could do backup, critical loads backup. I wouldn't back up the whole home, obviously. Yes?
Also, there's some small off-grid systems that go with a small solar 5K or 8K with a single battery and a small cabin, and that's good enough.
Yep. Yeah, so and I'll show a package with that. And then a double stack, you can do 10.6 kilowatts of power out of a 2 stack of these batteries. Notice that it didn't just double. I take the 6.6 kilowatts of power out of a single battery, but I can't do that out of 2 batteries. And the reason is that once we start stacking these batteries, we have to make sure that we're drawing equally from the bottom battery, the top battery, etc. So there's a little bit of derating as we start stacking the batteries. So, and then once we have a 3 stack, we're up to 14 kilowatts of power out of a 20 kilowatt hour battery. So plenty to power a Sol-Ark 15K that will pull up to 275 amps. A Sol-Ark 15K will draw at maximum 12 kilowatts out of batteries, and our battery is capable of 14. So, like I said, we've designed this specifically for the 15K. And then you can always parallel batteries and put more batteries to your system. So you can do up to 84 kilowatts of power out of 6 stacks, and up to 120 kilowatt hours of storage. Yes?
But the battery, they are modular, so let's say the 3, and then you can go 5, 6, you don't really have to keep the consistency after the 3.
You don't have to keep the consistency. I would recommend if you're doing 4 batteries, not to do 3 and 1, but to do 2 and 2 to balance the batteries better. But yeah, you could do a 3 stack and a 2 stack.
Okay, got it.
Yep.
Can you do an off-grid system where so you can make your infrastructure?
I don't think I got all your question. Can you do an off-grid system? The answer is absolutely.
Yes. But can you use the battery for infrastructure?
EV.
Yeah. Yes. Yeah, we do not restrict.
We need to come down to charging speed for like 15.
So to give you a rough idea of size, like a typical, like Nissan Leaf might be 40 kilowatt hours, 50 kilowatt hours of storage.
Yeah.
A Tesla Model 3 is like 80 kilowatt
75.
hours. 75. 75. Okay, and then like the long range ones might be 100. I think what is the Cybertruck? Is it 120?
I guess it's a little more because of the weight and the autonomy.
It's very heavy.
Around 150 maybe.
Yeah. But that gives you an idea. So can you charge off of these batteries? Absolutely. We don't restrict that for warranty. There's no problem doing that. It's just that you won't be able to store a full amount's worth of charge. If you drive your car all the way to 0, you'll only be able to charge it up maybe to 50% or something. But absolutely, you can do a class 3 charger off of that. I mean, you could.
But do you have a limit how much you can put in the charger? Is it 15 amps, or you have full, you can go for like you have an 80 amps?
Well, your limit is 200 amps.
Yeah.
And that's including
But you
pass.
have no problem with the batteries for.
You won't have a problem with batteries. Yeah, the batteries, and you can limit how much power you're pulling out of the batteries if you want to as well. So let's talk just briefly about how to combine multiple stacks. So if I have 2 stacks of batteries, because the Sol-Ark has dual inputs on it, if I have 2 stacks, if my training wall was bigger, or if they gave me more money for a training budget, I would have 2 stacks of batteries here, and I could bring both of them into that Sol-Ark 15K and have no problems because the Sol-Ark 15K has dual inputs on it. But what do I do if I have 3 stacks of batteries or 4 stacks of batteries, etc.?
Have to go combine it.
You have to go to a combiner. Yep. And so there are different combiner options on the market. John, we have a 1,000 amp combiner, right? It's a Boss 6,000 amp combiner, so it takes up a lot of space. I think you're working on a 2,000 amp.
Yeah, we have a 1,000 amp coming up, combiner coming out. It's about the size of the 4.9 battery on the wall there. It'll be coming out pretty soon here, probably in the next couple months. Outdoor rated, powder coat, nice and white, just like the batteries are now.
So essentially it would look like this without the conduit cover on the top, right?
Yeah, and it'll be a hinged door that opens up, yes.
Okay. So that's one option for outdoor. The common one that everybody uses is the Midnight 1000 amp combiner. Are any of you familiar with that? Okay, the 4 stacks that are in my van that are going up to the install this week, those 4 stacks, there's a 1000 amp combiner. It's 24 inches by 36 inches tall, so it takes up a decent amount of wall space. But drawing from the whole bank, I'm not drawing more current out of this battery or this battery, or drawing too much current out of an individual stack. And that's why we require overcurrent protection on them. The Sol-Ark 15K has dual 200 amp breakers on it. But you can buy, there are breakers on the side of this 1000 amp combiner. They don't come with it. So the combiner itself is about $600, and then you have to buy the individual breakers for about $100 each. I'm going to show you a cheaper option here in a minute. Another option is the Midnight 250 by 2. So you've got 2 250 amp breakers coming into that. Each of these battery stacks is capable of 275 amps, so the 250 is right about at the right range for that. But again, a little bit too small to do 3 or 4 stacks. So I'll show you another option. This diagram here is to represent the Midnight combiner that's here. So you would have, if you have 4 stacks, you would have, you only have to have, on a DC device, you only have to have single pole overcurrent protection, right? You only have to interrupt one side of a DC circuit to interrupt the current. You get people that'll do too many breakers, right? Cost themselves extra by doing the negative side. So you only have to have it on one pole, the positive or the negative, doesn't matter which one you put it on. But so those blocks there are to represent the overcurrent protection. So,
I got a question. The
yes.
box got wired the way I see it.
This one, yes.
The disconnect that you have over there.
Oh, here.
To the right.
Yes.
Picture of the disconnect.
Picture.
The red button.
The Rincon disconnect? Yes.
Where does that get them?
So that could go, it's not required because it depends on your AHJ, but if you've got an AHJ that requires a DC disconnect, you could wire it between the battery controller and the Sol-Ark. So these are surface mount. So you could get an enclosure and mount that on the surface. So you get an external enclosure, mount that on the surface. John's
that one right there, the gray one's got those disconnects.
Yep. John's got switches right here, so they're DC disconnects that are here. So those aren't necessarily required, and they're not required by us, but if the AHJ wants them, that's why I'm showing you.
Usually required by a fire department. With special yellow plastic stickers.
I didn't hear the
They're
question.
usually required by the fire department. I work with LA City,
Sure.
LA County, and they usually overkill everything.
Of course.
Well, it's for safety. Okay, but bottom line is you have a lot of like multiple safety breaker systems.
Yes, right.
So you guys have that in your thinking with what you're producing.
Right, yeah. That in the combiner that we're designing, that's coming out shortly, each battery will have an individual breaker inside the combiner as well.
And the
They don't,
Sol-Ark-
Sorry, in
they don't
addition
wanna
to
go
that,
inside, they
yeah.
wanna go on the outside, hit a
Oh.
switch or pull a lever. That's their
Understood.
thinking.
So you're right, and
That is what they want, yeah.
some jurisdictions want the DC disconnect, which is why I'm showing it here, right? The majority of our installs, the inspector does not ask for a separate DC disconnect. But
And the reason for that is the emergency stop that's built into the Sol-Ark device.
Yeah.
Right. So when you trigger that rapid shutdown button, the big yellow and red one, that
Right.
does stop.
So
the
this is
production.
going to do several things. So one, if I push this button, it's going to shut off. It doesn't shut off the grid. It doesn't shut off utility, but it's going to shut off all the loads. So now the whole house is shut off. All the loads in the house. There's no power coming out of this. It does not shut off the DC battery. But for a low voltage system, according to guys that I've talked to in code, so one of the guys that writes the code, it's not required. We don't have to put it in. But if you do have an AHJ that's saying, hey, we require it here, then the nice thing about these Rincon switches is they're rated to 1,000 amps, they're rated to 1,000 volts, and they're a 600 amp disconnect. If you go on Amazon and you try to buy a switch, you'll get one that says it's a 500 amp disconnect and it's rated to 48 volts. Well, these batteries are actually operating at 55 volts, right? So technically you're going over that. The other thing that's nice about the Rincon switch is it's UL listed, right? So it's a quality product. Yeah, it costs $100 as opposed to 16, but you know, for safety reasons, if you buy one of those cheap switches that you can just get off of Amazon, it's going to heat up. There's contact resistance in the switches. So when switches work by bringing two surfaces in contact with each other, and if there's not a lot of pressure, there's some contact resistance. And if you have resistance and lots of current flowing, you are generating heat inside the switch. So I've been on forums where people are complaining, hey, this 500 amp switch I'm using 100 amps and it keeps heating up and getting really hot. Well, it's because you bought a really cheap switch. So this is a good option if they're requiring it for you. And John's got it built in. So when we take a break, look at the side of this outdoor enclosure here, and you'll see two of these switches mounted on the surface here. And that'll turn off, I'm guessing, the top 3 batteries and the bottom 3 batteries for our system. Okay, so good question. So let me show you one more option for combiners. I didn't want to spend a ton of time on this, but you can use fuses as opposed to breakers, and the fuses are a much cheaper option. So here's a Victron product that one of our former colleagues who used to work for SimpliPHI worked for Victron. He's a Victron dealer now, and he let me know about this stacking combiner. So this is a Victron Lynx 1000 amp combiner. It's $170 for this. You can position 2 Class T UL listed fuses between the 1000 amp combiner bars, and that gives you overcurrent protection on the positive bus. So this would be a battery input here. This would be a second battery stack input here, and this would be a positive overcurrent protected DC bus. And then the negative, you can't see it, but the negatives are behind underneath the positives. So the whole thing is about 2 inches thick. And for 4 stacks, you would need 2 of these things, or $350 worth of product, and then you can do it with fuse. So I'm showing here 6 stacks. These things are stackable, so you can connect these 2 on the right side of the next one, etc., etc. So you can stack. I don't know how many of these. I don't know the limitation, but it's more than 3. So you can stack those up. So this is a nice option for a combiner. Rodolfo, this is the one I was telling you about as a cheaper option to the Midnight. And you can mount those in a wire array or mount those in an enclosure. There are other ways to do combining as well, right? So the Blue Sea Fuse bus bars are options, and you can use these fuses just go right on the top of a bus bar. So if you had a bus bar with multiple studs, multiple 3/8 studs sticking out of it, this fuse you can mount. So you can mount your input here and your output there on the bus bar, and that way you can do overcurrent protection on each stack that's coming in. Okay, so I want to advertise a little bit. You can do some online learning with us through our Power Academy. I also want to point out that Sol-Ark has Sol-Ark University, and you can get training with them there online. And to install the Sol-Arks, I think you have to do 3 installs to become a
3 or 5, right? And it's a couple levels of certification, and just by getting a little bit higher level of certification, you could do some more advanced features, repairs and things like that if there's ever an RNA or things like that. So.
And again, they've got great tech support, so you can reach out to them if you have questions as you're doing your install and work through it. Another advantage of going with Sol-Ark. So I told you about packages that we're going to offer. We're going to take a break here in a minute. Food coming?
It is. Yeah, I think we're T-minus 15 minutes.
Okay.
Yeah.
Okay. I was expecting you guys to be eating while I was talking, so. So we've got, Briggs came out with 3 packages to just guide homeowners in their purchases, and I'm going to talk just briefly about these packages. The one that we see selling the most is this whole home power. Almost everybody is just going with a Sol-Ark 15K, maybe starting out with a single stack with the idea, okay, I'll add more batteries next year, and then I'll have, backup for 3 days or whatever it turns out to be. So I'll show you but we did this to estimate how much backup time customers would get, because that's the first question you get. I mean, the first question when I installed my battery system and my neighbor came over to look at it, and he was like, how long does it last, right? I mean, that's what they ask. And so we're trying to guide that conversation a little bit for you. Managed power, we're expecting you to use a Sol-Ark 12K, back up 75% of the home, but maybe leave the water heater off or leave the spa off or whatever the load is that they don't really need on there. Maybe even the air conditioner, right? If they've got a 3-ton AC unit that you can't back up. And then essential power, you just back up about half the loads in a home. This is where you could just use a single 6.6 battery, come in really low cost. So the components of the essential power, you would use a single battery stack with a Sol-Ark 8K. You back up maybe half the loads in the house, the lighting, the kitchen, refrigerator, obviously, your communications. We're not selling a lot of these, I don't think, but there are cabins, there are places where people do want a smaller system because they don't have a lot of electrical loads. And to give you a rough idea, the average house in the U.S., 24-hour, 365 average, is drawing about 1.2 kilowatts as an average, right? Now that doesn't mean during the day it goes up. It might be during the day, it might be 2.5, but at night it might be 0.7. So the average house in the U.S. From the U.S. Energy Administration is 1.2 kilowatts of power as an average. So if you're backing up 50% of the house, this system with a single battery would run for about 11 hours. Back up half the house for 11 hours, low-cost entry system. What the package includes is you get 63 amps of pass-through with a Sol-Ark 8K, so it's about enough to back up about half the loads of the house for a medium-sized home. And then it includes the monitoring platform with Briggs. It includes the My Sol-Ark app, etc. The managed backup is where you've got most of the house backed up, but you might not back up the air conditioner. You might not back up the water heater or the spa, etc. So you're going to back up 75% of the house. Again, assuming the same average amount of power draw, and that 75% of the house is backed up. With this size battery, you get about a little over half a day of backup with this. And then for a whole home, with a single stack, so a single stack of these batteries, the Sol-Ark 15K, you back up all the loads in the house. We're assuming they draw the national average. The rough idea would be that they would get about 16.4 kilowatt or 16.4 hours of backup, right? So about 2/3 of the day for a single stack. Just to give them a rough idea, obviously, if you've got a tank of energy and you turn everything on, you can use it faster, right? This is only to give guidance to customers on how much backup time they're going to get.
I have a question.
Yeah, go ahead.
Which particular product is controlling how it's controlled or not?
So the Sol-Ark is taking the power out of the batteries and supplying them to loads. There are settings within the Sol-Ark that we are going to get into in the next, after lunch, we'll get into in the next session, where you can do some managed power. One of the questions that comes up often is, hey, can I turn off specific devices based on battery percentage? So that's smart loads panels like the span panel. Lumen offers individual load shutoffs. Yep, so span. Yep.
Also do Savant.
You do Savant as well. The challenge with I think Savant and Span is that they do not have integration with Sol-Ark yet. So I can't send information from the Sol-Ark directly to the Span panel. And I don't know if that'll change. I thought Sol-Ark was coming out with one, but I don't have more information in that.
But with Savant, I can control the breaker.
Yes.
Or if I'm controlling
Oh,
the
you
breaker.
can absolutely use the span panel with the Sol-Ark. There's no reason this panel here can't be a span other than my budget. But and then you can use that app to turn devices off.
But doesn't that stretch the amount of storage life?
Yeah, absolutely. You would get right, and you would get much longer duration backup if you had a smart loads panel. Yes.
That's the
And-
future, definitely. That's
And so
It's gonna be on every job.
yeah, so Lumen is another option where they give, Lumen is the one that has the individual, right, so
That's correct.
that is smart. Okay, so that's, I was getting confused, yeah. Yeah, so absolutely you can do load control.
Well, it is installed and functioning right now.
Yeah. Yeah, I didn't mean to imply that this doesn't work with those load centers. It does, it's just you can't do it through the Sol-Ark app.
Right.
You have to close them through the Savant app. Yeah.
But it doesn't, the battery doesn't.
No, the battery doesn't care. It's just going to get longer lifetime out of the battery. So yeah, absolutely, you can get more hours of backup if you smartly adjust your behavior once the grid goes down, right? But I will tell you something else, that the average duration backup in the U.S., at least a couple of years ago when I looked at the data, is only a couple of hours. The average duration outage is only a couple of hours. That was then. Yes, they might be increasing. And if you go through a fire and you have a 2-day, 3-day outage, and you're not really going to be comforted by the fact that the average of the country is only 2 hours. Yeah, no, a lot of people want longer backup. Now this is not including solar, right? So as soon as you have solar on there, you know, you get through the nighttime with your battery system. The next day solar comes out and your battery gets charged back up. So you can have essentially indefinite, if you have enough solar, indefinite amount of
But that's why you have your small little generator at your.
emergency.
Also-
That's your third, exactly. So I mean, you guys, they were talking about, you know, 3 levels of safety, of backup. You know, you've got utility, you've got a small portable generator that you can't do everything, but you can do, you know, much of the house with. You've got your battery system, you've got your solar, right? A portable generator you get for $1,000, and this will take it. So,
Yes, it can, but then you need to have a manual transfer switch, so you don't backfeed it.
this thing is smart enough to know when you've got a generator connected to it. So in terms of backfeeding the grid, you don't actually have to know about that with a Sol-Ark. So with a Sol-Ark 15K, if it starts to backfeed, what happens on the grid is when the generator, when you start backfeeding the grid, nothing happens to the voltage, right? The grid is essentially stable, inert to us pushing a little bit. So the inverter leads the phase of the grid electricity a little bit and pushes electricity back to the grid. That's how it backfeeds the grid, right? When you try to backfeed a generator, all of a sudden the voltage of the voltage regulator in the generator starts to rise, and this stops backfeeding the solar. So you don't have to worry about the Sol-Ark backfeeding your generator or backfeeding the grid. It won't do it. It's built in that it's smart enough to know that if that voltage goes up as it starts to backfeed, to stop backfeeding.
It can't handle all 3 of those backup methods at the same time.
The only time the generator port on the Sol-Ark is going to work is if the utility port doesn't have any power on it. So as soon as there's 240 volts of power on the grid port, the relay for the gen port is ordered.
Yeah, but I'm just saying for like your overkill people who like have solar, battery, and the backup generator, it can manage all of that.
It can manage all of that, yes.
Can you program it so that the generator's feeding the battery even if there's grid present?
Yes, we're going to get into that in the next talk. After lunch, I'll get into more of the details. Yeah, I was really focusing on the batteries here. To be honest, I'm pretty much done with this. I'm going to talk to you about some co-marketing stuff, which Brian can supply you with images, with that kind of thing if your sales team needs assistance. There is a program to it. So this is just a summary of those. This is a quick look at Energy Track. Yes.
On the previous slide, those packages are just like options, but you guys, the cool thing about these systems, you can size power and energy independently. So if you cover your power with small inverter, you can have more batteries. So you can have your 8K with 6 batteries for a longer duration.
Yeah.
And you can have multiple inverters with small battery banks, so you can size power separate from energy.
Yeah, and that's a really important selling point for us, right? You want to back up with a power wall, you can, but you've got the inverter integrated into the power wall, and right now at least, I know they're supposedly coming out with a power pack. that's kind of similar to this, and that you can do batteries separate from inverter. But right now, if you want more storage, you've got to buy 2 power walls and increase your power and energy at the same time. With us, like Rodolfo said, you could have a small battery because you just want a very short amount of backup time from the battery, but you could have, you know, multiple inverters, or you could have a very large battery bank and just a single inverter. So you scale the energy separately from the power.
But what about the time of use?
So for time of use, this can do time of use as well. We'll get into those settings a little bit. Actually, I think that's one thing I meant to review that this morning, and maybe you can talk about it a little bit more than me. I'll get into those settings and I'll show you how to do it in Sol-Ark, but it's somewhat sophisticated, and you can control independently if you're going to sell from batteries back to grid, or if you're going to, you know, just not sell, but time of use you can limit. Hey, I only want to use this amount of power during this window because electricity is expensive. You can do limited power at home so that you can, you know, you can say I don't ever want my house drawing more than 1 kilowatt from the grid. There are settings for that, and I get into that.
You can do that through the app or when you commission the
You
system?
can, yeah,
You can do-
the app or
Yeah.
directly on the Sol-Ark display.
Yeah, you can do it with both. So we'll get into that next talk. I'm basically done. I did want to point out that these are the different inverters that Sol-Ark has available, and I'm going to give you this slide deck so you have all the specs. But I just put this table together with my colleagues so that you would know, you would be able to compare. Like for instance, on a 30K inverter, how much solar can you bring in? Well, you can bring in 39 kilowatts of DC solar. You can bring in another 30 kilowatts of AC coupled solar. And so it's 15K, the specs are there. Anyway, I put this together. Sol-Ark's going to pay me for it.
That's right.
But that's kind of, this is their full inverter lineup here. The one thing I do want to point out about your 8K, and I just heard they're coming out with a different one, but this is the only one you can't parallel right now. Okay, so I can parallel two 12Ks, meaning I can take two 12Ks to get a 24 essentially, but you can't take two 8s and get a 16. It was the first inverter they came out with, and it didn't have parallel built into it. I think that's changing in the near future, but all the other ones, so like I can put up to 12, 15Ks in parallel. And I'll show you some pictures. We've got plenty of installers that are doing like microgrids and stacking 6, 7, 8 inverters together. If you do multiples of 3, you can do 3-phase with the 15K to 12K. It'll do 3-phase 208. You can actually do 3-phase with just 2 inverters, but it won't be balanced. And you can do 1 inverter. Actually, this one until today was in my workshop up in SLO, and I had it running off of 208, but just 2 legs. So you can configure it to work in about any situation. But if you do get big, you might want to go to Sol-Ark 30Ks and 60Ks when you're doing 3-phase. Either 208 3-phase would be the 30K. You can parallel up to 10 of those units, right, to get more power, to get more solar input. So they can go, you can get quite big on these.
But unfortunately, the 30K is not available on 480 from what I heard, right?
30K does not do 480.
Yeah.
So if you want 480, you got to get the 60K.
It's overkill for the Titan 24. I hope you guys will do something about that soon. Because, everything with Titan 24 commercial one, we look for an option, it's like 60 is too much budget-wise, and those GC, they are just looking for the last penny, and when you keep them prices, they shit, no.
Right, exactly. And well, sometimes transformers could be used. To my
Yeah, but the
knowledge,
funny thing is,
to certain
I give them that option, but they say, no, I want to go for it straight from there. So, okay,
Yeah.
that's the pricing point.
A transformer is $2,000.
I
Well,
know, but
maybe
it's just-
3,000 for, so I think that's
It's
how much,
stupid.
if they want to
So-
save money.
Yeah, that's why I tell them, but,
Yeah.
they ask, I give them the option, they say, okay, let me think about it.
Yeah, and I'm going to be putting together a talk on high voltage for later this month, and we'll talk about some of those options. I'll also be talking
Because
about using transformers.
Anytime soon is going to be like super high demand on that side because of the Titan 24, and it's a must. Anything you do, like, you
You just have to increase their budget so they buy the 60K.
It's good feedback, definitely.
So I wanted to show just a couple of, I guess we're still waiting on food, or am I holding this up?
No, I think we're moments away.
Okay, so did want to point out some code related considerations where you're putting the batteries. So this is from Mayfield Renewables. Ryan Mayfield is the one who I was talking about. He's part of the group that writes the NEC code. And I was talking to him about whether or not a disconnect is required from code perspective. It's not, but some local fire departments do require it. We get plenty of phone calls in which we've got a fire department or a fire official that's very adamant about something that's not necessarily national, but it doesn't matter. If the local authority having jurisdiction requires it, then you put it in, right? It means you buy better coffee or donuts or whatever you get. So just a couple things. Batteries should not be within 36 inches of a window or a door. You can do up to 80 kilowatt hours total on the exterior of the house. You can also have an exterior utility shed, like a detached utility shed, and do more power, more energy storage on that if you need to. In a garage, you can do up to 4 stacks of batteries in a single garage. You shouldn't. This number is going to 600 soon. I mean, it's kind of silly that you can pull 300 kilowatt hours of power into your garage and that you have a couple of cars, but you can't install more than 80 on a mounted, safety tested battery on the wall. But that's what the limit right now is 80. If you install on the back wall of the garage or even on the side walls where when you pull in, if you think that if you could hit it with your car when you're pulling into the garage, you either have to elevate it off the ground high enough, I think it's a 24-inch limit off the ground, or you have to put some type of protection in it so you're not bumping into it. The nice thing with this battery is that it's thin enough, you can put it right on those walls, right on the side as you enter into the garage, and then you don't need parking ballards, etc. We do have a section where we break out, like I said, Daniel's going to go through the code talk, we break out in the garage where are those regions, etc. Just want you to know that there is code around where you should be putting the batteries. So that'll come out when you do your application, your original design, when you send that off for your permitting process.
But the equipment-wise, what is the minimum space between?
36 inches between.
From the manufacturer?
Yeah, that's 30. Well, no, that's part of the NFPA 855. It's 36 inches between.
36.
Yep.
Because some other.
That's what?
They go 6 inches.
Those change, and we can do additional testing with UL to get those reduced. We haven't done that yet, but we could get those even tighter. So there are some manufacturers that pay for that extra testing to get your batteries even closer.
Yes, but now it's 100% true because LA, for a matter like LA county or jurisdiction, they no matter what, even it says the manufacturer 6 and certification UL anything, they still want to go with 36. Just
yes.
Like you mentioned the jurisdiction, but if you guys already from the beginning to start with is 36, then that's the way to go.
We have very few cases where we communicate with the AHJ and they change their mind. So it's normally if that's what they want, then that's what you have to go with. And if LA requires 36 inches, I mean that's the requirement for us anyway, right? According to code. So
for now, yeah, but like I'm saying, in Orange County, I do the same installation compared with LA. I can go 6 inches, spacing batteries next to each other, right? Based on the manufacturer specification, documentation. If I go LA with the same,
yeah. Well, all of this changes, and every 3 years we get new code, right? And like I said, the next version that's coming out, you go from being limited to 80 to being limited to 600, right? So battery storage is changing. So I don't want to hold you up from the food. You've seen the wall bracket. I'll have a video that plays that shows John and I building the bracket. That video will show you all of these things like the connections, etc. And if you have any questions, ask me. Let's get some food and take a break. Thanks for listening so far. Yeah, a little bit. So there's the waterproof connection for the battery is made through 2 pieces. So this is your battery compartment. You make your connection there, but you're going to have 2 plates. One that goes on the side here on the front, and then another one that goes on the top to make the waterproof enclosure. And then there's a plate that goes on the outside. So this is the first. This is through the side where you're going to run all of your cabling through. so I'll secure that in place first, and then I'll secure the battery cables down. And so this top plate here that I'm screwing down now, so I've already connected the side plate on, and then I'm connecting the top plate on now, and so this bay is now waterproof. So where the cables are coming into, but notice that there's still an opening on the side here, and that's where that cover plate goes on the side. And that's what I was talking about earlier. If you take a close look at what I did here, you'll see I didn't quite punch it out all the way. If I had more time last night, I would have adjusted it so that this build looked a little better. So here's, I think there's a good shot. So that's the waterproof part, but you'll notice that you can still see the shoulder tab there, etc. So there's another plate that's just a vanity plate to make it look prettier that goes over the side there. And because of the way that it slots down, you have to punch it a little bit, you have to punch it twice, once in the bottom and then once above to create an oval around it. Don't know that I'll get a good shot of that, but right there. So that's the side cover plate. So there's the inside cover plate where the waterproofing is done. And then now you'll see that there's this extra plate on the outside. That's just to complete the look. A lot of people aren't installing that. But if you do install it, you have to punch it once, a 2-inch circle at the top, and then punch a 2-inch circle at the bottom to slip it over. Okay. So I want to get into the settings on the Sol-Ark, which kind of the second part of the training is more technical. And first, just want to point out again, the bathroom is around straight down and on the left for ladies, and then for men, you got to go through the kitchen, which is round. But if you follow the yellow line around, walk through the kitchen, through the door opposite to you, and then there's a door on the left for the men's bathroom. And don't worry if you have to get up. You're not going to disturb me. So if you need to take a call, etc., feel free to get up as I'm talking, and feel free to interrupt me at any time with questions.
We got a question. Question.
Yes, go ahead.
Is there any type of heat regulation in the battery? How does it ventilate? Is there a heat sink?
There is a port. Hey John, do you have one of your number 1 screwdrivers? Actually, E, and then
I don't have it right here. I'll
so I don't think they don't need to see it, I guess. But there's a port on the top here for venting. Thank you. That is a prepared install. I don't use Husky brand. So if you look on the very side here of this battery, it is a sealed battery, but there is a port in case of an off gassing, and this port will open up to allow off gassing if it needs to.
It just runs through the stack.
It runs through the stack, it runs through the rapid stack connector. Yep. Thank you. So good question. Are there any other questions on the battery before we jump into it? There'll be some more slides on the battery here, but mostly I'm going to talk about what you can do with a Sol-Ark and how to use the Sol-Ark with generators, how to set up the Sol-Ark for time of use, that kind of thing. So go ahead.
Yeah, with the connections, have you had any issues with like any sort of corrosion or anything with the quick stackable kind of?
None, but the battery's very new. I don't anticipate that we're going to have any issues with the connection. These are copper, but they're tinned copper. So all of the connections have a zinc plating on top of the copper. And so I doubt we'll have any issues with corrosion. The one issue with corrosion that I would expect could happen is if you do something like a knockout on the cover plate, like what I was talking about here with this cover plate. So if you do a knockout, then you're going to have exposed metal there. I always just take a little bit of spray paint and spray paint over exposed metal.
RTV sealant, something like that.
Yeah, something
Clear
silicone,
RTV
anything to
actually,
cover the
Seal
exposed
it,
metal
yeah.
if you've done a punch out deal. Yeah. Good question. Don't know what I did with my. Okay, so Kyle, I didn't put your name on here. I took my name off. We've done this slide with a couple of different trainers, this slide deck with a couple of different trainers before. Liam, who's the product manager for Sol-Ark, but Kyle Bank is going to do this with me. We're going to walk through communications, but it really is a slide deck on the whole Sol-Ark 15K options that you have. We'll also talk about integrating our generators with it, but what I'm telling you about our generators works equally if you're trying to integrate a Kohler or a Generac or other generators. As long as they have 2-wire start, the Sol-Ark can control the starting and the stopping of the batteries to charge, or starting and stopping of the generator to charge up the batteries. So there are a lot of applications for using Sol-Ark and battery backup, and we talked a little bit about why people are doing it. But the nice thing is that you can bring solar in to charge up your batteries, use those batteries at night, so that that energy you're generating during the day, you've got it whenever you want it. I do point out that a lot of homeowners that have solar on their roof think that they can use solar power when the grid goes down, right? And it's not until they experience the fact that, well, if the grid goes down, the inverter goes off unless you have batteries attached to it. So if you don't have batteries, you can't use your solar, even though the solar is capable of producing with the grid down. The inverters themselves obviously have to shut down to prevent backfeeding the grid, because a grid-tied inverter is there to latch onto the frequency, the signal from the grid, and then send any excess power back to the grid. So,
Hey, Nathan?
yes.
Sorry, do you think you can zoom in a little bit?
Maybe. We'll see if I can keep it balanced and oops, wrong one.
Not a big deal.
So zoom. Now it's zoomed in all the way. I can do the mechanical zoom and slide the whole cabinet. But can you guys see all right? Is it just Brian? I mean, he's probably the oldest.
Yeah, everything else in my body's failing.
All right. And you guys, we all understand that you get some utility bill savings with solar and batteries. When we combine storage and renewables, we've got a lot of options. We can do off-grid. So not all companies warranty their products for off-grid, but both Briggs and Sol-Ark do. Like for instance, if somebody's got an off-grid site and they want to do a power wall, too bad, right? So you need to use a company that warranties for off-grid, and we do. And then the other thing, yesterday I had a conversation with a couple of guys that are doing containerized battery solutions, and they're doing them for, right now they have some military solutions. They're building out 20-foot shipping containers with our high voltage batteries and with your high voltage inverters. And they're very interested in optimizing generators, right? So you can imagine in forward operating bases getting driving a diesel truck to supply, the fuel for even just for housing for troops. It's not an easy thing to do. And so they're looking at trying to use less fuel by having deployable solar. So they've got this accordion style racks for solar that will pull out of the bottom of the shipping container, and then they have our high voltage batteries mounted at the top of the container, and then they've got the Sol-Ark inverters. Well, generator optimization, right? That's the thing that people often don't think about. So they do have generator backup. It's just they want to run the generators as little as possible because it's hard to get the fuel. Same thing happens for communications towers, etc. They're on the top of the mountain. A lot of those have traditionally had, for when the utility goes out, have generators to back them up. But again, getting the fuel up to the tops of mountains is not easy, and so there's communication companies that are doing a lot of things with generator optimization, and really a hybrid generator, right? It's a generator with batteries attached so that you run the generator a lot less.
Or the, uncommon scenario where you have a 2-week stretch of, rain, in some location that you have that generator backup just in case for a couple times.
So we'll go into how to integrate the generator. We'll talk about different ways to integrate, but I'm going to focus at the beginning here just on closed loop communication. So our batteries have closed loop communication with Sol-Ark. What does that mean? Well, the inverter it's a hybrid inverter. It's got the charge controller built into it. It's capable of charging the batteries from generator, from the grid and solar simultaneously. It's capable of doing all those things, but we don't want to just put a certain setting into the generator and say, hey, charge at this rate, if the batteries are in an extreme situation. So for instance, if the batteries start to get really hot because it's an insanely hot day, the sun is beating directly on the batteries, we want to slow the inverter's charge rate down. Or if the batteries are really cold because it's really early in the morning, cold weather, we want to keep the batteries safe, we want to charge them a bit slower. Well, how do we do that? How does the Sol-Ark know to charge the batteries slower? Well, the answer is closed loop communications. The computer inside the batteries is talking to the hardware control inside the Sol-Ark, right? So the software is communicating with each other. So that's what closed loop communications means. It means that the computers that are in the batteries are talking with the computer in the Sol-Ark, more or less. The software communicates. So we have closed loop communications, and the batteries will automatically adjust the settings in the Sol-Ark based on battery conditions, right? If the battery is really cold, it might slow the charging rate down. If the battery is getting full, it tells the Sol-Ark, hey, this is my current status, right? And the Sol-Ark can respond to the information coming from the battery. Each of these battery modules has multiple temperature sensors throughout the battery, and it's communicating temperature, it's communicating state of charge, state of health with the Sol-Ark.
And not all batteries do have closed loop, so that's a huge advantage of Briggs Stratton. It will have that full communication in these scenarios.
So it's dynamic performance, basically. It's the battery automatically adjusting its performance. And it's not just with our newer batteries. We have a history of working with Sol-Ark. So we have closed loop communications with these 4.9 batteries. We have closed loop communications with our 3.8 SimpliPHI batteries. And like I said, they adjust automatically based on the battery's condition. So dynamic power management, remote monitoring, so through the gateway that's there, we can monitor each of the individual batteries. The state of charge monitoring is there. Overcurrent and over voltage protection is built in. Cold weather thermal management, that's what I was talking about. The inverter responding to requests from the battery to change its charge rate to suit what the battery wants to keep it healthy. Energy management, lots of reasons to have closed loop communication. So this is showing
Hey guys,
you what the closed
one
loop
more reason,
looks like.
sorry to interrupt.
You're good.
One more reason is those closed loop batteries also come with a 15-year warranty, at least that 4.9 on the wall and the 3.8 kilowatt hour SimpliPHI. At the moment, the stackable battery is a 10-year warranty. So just as a heads up, even if you don't want the functionality, you want an extra 5 years of warranty, you might want to look at closed loop.
Yep. So we have some good options for you. This one is an outdoor rated battery. The 3.8s need to be an enclosure. I know a number of you that have been installing these enclosures. There's a Boss 12 right behind that yellow pole that's over there that'll hold 12 of the 3.8s. So it's a 45 roughly kilowatt hour battery bank. And all the busing is already built into it, etc., to make it pretty easy to install. Outdoor NEMA 3R rated enclosure. Temperature fans that come on and off. We have some cold weather solutions we can integrate in as well. So just to point out what closed loop communications look like. So the batteries communicate through a protocol called CAN bus. And CAN bus allows the one battery to communicate with the next, but they call it a bus because the batteries are all connected in a line and only the final one is connected to the inverter. You want to make sure that you don't have any open battery ports on those batteries. So, I was about to pick on installers for losing this, and then I wasn't sure if I knew where it was. So we ship this with every one of the amplifiers, every one of the SimpliPHI batteries, the 6.6 battery, they come with this, what's called a terminating resistor. And it lets the batteries understand that, hey, I'm the last one in the line, right? There's nothing, don't expect communication from the one to the left of me, etc. So when I look at this bus and I've got 4 batteries there, the very first battery wouldn't have anything in this port unless because it's the first battery, unless I put a terminating resistor. This is a little, I think it's a 120 ohm resistor that shorts out 2 sets of pins in the CAN bus loop. This gets thrown out occasionally. You know, you unpack the battery and you know, you already have your own cables, so you decide not to keep this one and you throw it aside.
The smart guy to take out the battery from the box, right?
Yes. So anyway, just make sure you don't lose this. You'll end up having a bunch of extras after you've done a few installs, but you want to make sure you never to have an open port in the CAN bus chain. And then the last battery in the chain goes directly to the Sol-Ark. All of these batteries, the stacking batteries, the cables, there's no cables between because it's all done through the rapid stack connector. But you'll still have one final run from the controller to the Sol-Ark inverter. And all of those are done with RJ45 connectors, which is what you guys know as the Ethernet cable. It's just Ethernet cable that goes Cat 5 or higher is what we ask for. Cat 6 is shielded, so there's some shielding to prevent, you don't need to use that. We recommend Cat 5 or higher. So that's what the closed loop communications look like. This is what it looks like on the, we're seeing some SimpliPHI batteries here. There's a 3.8s with some bus bars that are there. And so there's a terminating resistor right there, and then this battery goes to the next battery. That battery goes to the next battery. And if you're paralleling Sol-Ark inverters, it's the same kind of thing. You go in a big loop, so you go from inverter 1 to inverter 2, inverter 2 to inverter 3, and then inverter 3 back to inverter 1. You have a big closed loop. Okay, so this is showing a rendering of the 6.6 with Sol-Ark. I hit these slides earlier. I am going to talk just briefly about Briggs Stratton. So it's a household name. I think 70% of Americans have some Briggs Stratton product in their households. When Briggs Stratton first bought SimpliPHI, I had, what did I have? I had an air compressor in my house. And then you had a weed eater. But I know Briggs Stratton engines from lawnmowers. A lot of engines that you'll see on generators might not be a Briggs Stratton generator, but a lot of the portables, those engines were built by Briggs Stratton. Still building engines in the U.S., right? So U.S.-based manufacturing, been around since 1908, so almost as old as Brian. And sold in more than 100 countries. Like I said, I lived in West Africa for a while. We have a Briggs Stratton dealer in Ghana. So they're everywhere. So it's owned by KPS. Capabilities, we've got regional headquarters. We've got 40,000 servicing dealers worldwide, 13 manufacturing facilities. Like I said, still manufacturing in the U.S. You know, our factory over here is proof of that. We also have another battery factory in Alabama that is making NMC batteries, so for portable equipment. So Vanguard Batteries is a very large factory, much bigger than us actually, and they're making equipment for, you know, those portable lights that you see for construction sites, the forklift batteries, that kind of thing. We have hot swappable batteries, and that's been growing very rapidly. We've got a large manufacturing presence, and when they acquired SimpliPHI, it allowed us to utilize a larger set of engineers, a larger set of factories, etc., and expertise. And we make, obviously, both generators and batteries. The SimpliPHI batteries here, but generators are actually a bigger part of Energy Solutions. I think you told me is something like 80% of Energy Solutions is our generators. Yep. Something like that. So I'm going to let Kyle talk through about the Sol-Ark. These are some slides talking about some of the products we've discussed before, but I'll let you talk about this. Here on the screen. Do you want this?
Oh, sure.
Okay.
So, yeah, so, 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 so,
So I mean, Nathan's pretty much covered, you know, a lot of the, you know, inverters that we use, but just to review again, you know, we kind of have our full lineup with, you know, our 5K, our 8Ks, 12K, 15K, for single phase. And then for 208 volt, we have the 30K inverter, 60K for 480 volt, or 480. And then we also have high voltage batteries, you know, as well for both 208 and 480.
What do you guys think the 2P stands for on all those models? Yeah, 2-pole. So we're used to thinking we have single phase, right? We call our, you know, in Europe, you've got Europe, West Africa, China, you have a neutral wire which carries no voltage, right? That's your return. And then you've got a single live 230 volt, 240 volt, right? So when Sol-Ark, which is an international company, when they advertise their inverters, they advertise that as single phase, right? So the 2P there is two phase, 2-pole, right? So you have 2 live wires and then a neutral in between. So a neutral is at 0, and then you've got a 120 and another 120. So that's split phase, 2 phase. So when you see the 2P there, it's just because they want to distinguish between an inverter that, now you can switch them. You can switch this inverter will do single phase. But that's what that model number means when you're buying it in the US.
And then there's a couple other frequencies that you could do, and I don't know if anyone does installations in other countries, but compatible in Puerto Rico, Latin America, Mexico, things like that.
And we ship a lot of our batteries and Sol-Ark inverters to different islands, especially in the Caribbean. Things get pretty wonky when you're dealing with very small grids. And you know, there are places in the Caribbean that'll have 50 hertz, but be 240 volt split phase, right? They kind of mix and match things from Europe with the US. And so the nice thing about the Sol-Ark converter is you can just go right to the settings and adjust. Like I said last night, I switched this inverter from 208, 2 phases of 208, to split phase 240, which is what's coming out of this. You can switch it between 60 hertz and 50 hertz. You can switch it between, you know, having 1 pole at 240 or 2 poles at 120, right? So these inverters are switchable, but keep in mind if you buy a single phase inverter, it might be built for that market and the hardware might be different.
And then you have those interesting use cases, like if you have a well pump at a property, you know, you could use something like a 5K or 8K to just power that well pump, essentially. Not even be connected to everything else. So it has some interesting use cases, a lot of versatility that you can do with Sol-Arks versus, you know, anything else that's really out there.
So what are we looking at on the bottom right? Is that a 30K with the high voltage stack?
That's a 60K.
That is a 60K.
Right there. So that's the indoor version of our 60 kWh batteries. Also comes in a 40 kWh for 208 volt, and the cabinet to the right of it is the outdoor batteries. So it has full fire suppression on all of them. The outdoor cabinet also comes with HVAC and things like that. So completely outdoor rated, ready to be installed.
So Sol-Ark makes their own high voltage battery as we do. We kind of compete with each other there. They don't make a low voltage battery. And so, you know, we try to supply the majority of your Sol-Ark installs. We'll see how we do with this newest battery. But, you know, obviously we have some competition on the low side. On the high voltage side, we have solutions, they have solutions. And that's their outdoor enclosure for their battery to make it a NEMA 3R enclosure.
Yeah, just kind of what we were touching base before. I mean, Sol-Ark's been around since 2013. We're kind of started in the DIY market. So that's kind of where we started. And, you know, really the tech geeks, you know, nerds, you know, we're loving our systems, and it's the programmability and versatility of it were really attractive. We've grown a lot since then. This is our, you know, the 15K is like our 6th iteration of our hybrid inverters. So we're kind of further along the line than any other hybrid inverters. So it's pretty exciting. We have been in the game a lot longer than anyone else out there with this type of equipment.
And I think a nice thing about a Sol-Ark is you get access to almost all of those settings, right? I think the difference between going with other inverter brands that might be more restricted on what they allow you to do is, I don't know, I compare it maybe to like open source code. It's not open source, but you have a lot of control over the settings with a Sol-Ark, whereas with a Powerwall, for instance, you don't have as much you don't have as much configurability, and that's what I like about the Sol-Ark is you get that the ability to change anything. Now that means you could probably mess things up too.
Yeah, it's
So with that power comes some responsibility, but
it's not quite as proprietary. It really is kind of more open source, a little bit more future proof. You know, the design for the 15K hasn't really changed. So really in the future, and especially the customers themselves, they'll be able to do a lot more as electrification, you know, advances more with electric vehicles and things like that, more electric usage in houses in general. This is going to be able to adapt to those versus, you know, kind of the standards in the industry are a little bit more restrictive and constantly changing. So you might have to swap a whole system in, you know, 8 years from now, whereas a Sol-Ark.
I'll give you a good example. SolarEdge, for instance, right? You've got all of these optimizers on all of these SolarEdge systems, and you spend a bunch of money to get yourself one of those SolarEdge 7600s or the 9600s, but now you want to integrate batteries. We've got to get rid of the inverter because that inverter can't support batteries, right? If you get something like behind him, it's improving with features with time, but it's an all-in-one unit that has all of those features built in from the start. So it's not as restrictive, and it's not a single use case. Let's suppose you started off with batteries that you didn't like with the Sol-Ark. You could replace that battery bank. You might start off with a lead acid battery bank because that's what the homeowner already has, and he wants to make it work for the Sol-Ark. You can do it. With a SolarEdge, well, you can't even add batteries to the SolarEdge inverters. I picked up a $4,000 inverter for $200 the other day from SolarEdge because you have to use it with their optimizers. You have to buy all the parts in their system. Sol-Ark doesn't even make the battery, right? They have 6 different integrated battery companies like us, Discover, HomeGrid, a few others. But you're not restricted to using only their products, which is nice, right? They welcome competition. Now you are restricted to only using our batteries, but just kidding. All right.
Well, and like Nathan said too, if you already have an existing system set up, solar could also be used in a great way to just keep that existing system and then add on with a Sol-Ark inverter to add that battery system. If you have an inverter currently at the house that's can't work with batteries, you know, you throw on an 8K or something like that, or a 12K, and all of a sudden you put the inputs, you know, directly from the DC system to Sol-Ark, and now you have a battery ready.
Let me give you another great example. Same thing. You've got that SolarEdge system up on the roof. Every solar panel has optimizers on it. Those optimizers will only work with SolarEdge. You don't want to have to re-permit and rewire all the solar panels on your roof. Just take the SolarEdge output, bring it in through the gen port on the Sol-Ark as AC coupled, and you don't have to re-permit the roof, redo all the installation on the roof. You can simply bring that SolarEdge inverter into the Sol-Ark. So, you know, it's a good inverter for retrofit. For another example, you've got a big Enphase system on your roof. Actually, I've got some slides in here from Enphase IQ8s that were on an install we did in Florida, and wanted batteries, so we bring that Enphase system in through the AC port on the Sol-Ark, the smart loads port on the Sol-Ark, and just AC couple that Enphase to DC coupled batteries. So you have, basically this inverter will work with almost any circumstance with a retrofit, right? The solar's already on the roof, but you want to add a battery system, you can use this one. I think if you use the advanced, I'll walk through, I think there's some more slides for you guys as well.
One of the keys of this industry is that if you're not setting yourself up to figure out to be as optimal as possible and the ability to get the stuff to figure 6 years from now, there's nobody in this room knows exactly what it's going to be.
Yep.
Then you're just putting the kiss of death on your system.
Yep. Well, that's how I feel. We have a Generac power cell system right now that I'm communicating with an installer about. It never worked, and it was a very small battery system. And every one of the solar panels that's on his roof, he's got 4 arrays on the roof, they all have the Generac optimizers. And finally, the guy who owns the house is a retired doctor, and he just wants it to work. And finally, he said, just rip it out and bring it through the Sol-Ark 15K. And that's what we're doing, because the Sol-Ark 15K allows you to bring other products in. It's not an exclusive product where it's like, I only work with products from my company that may or may not work, and may or may not work in the future. So SolarEdge is an example of that. Generac's power cells are an example of that, because they're very small. They're like 4 kilowatt inverters or something like that, and you can't do much with them. And then you can't integrate them with other products in the future. And I feel like the Sol-Ark is not that way. It's very open as to what it integrates with. Yes?
How does it work with rapid shutdown? Is it flexible like that too?
Yeah, so I'll talk about rapid shutdown, so I'll hold that question for now. The AP Smart will power itself directly out of the Sol-Ark control board. And then Tigo, you would do your power supply for is it Tigo or Tigo?
I would say Tigo.
Okay, so
Not sure.
Tigo, you would power the rapid shutdown transmitter out of your load center. But yeah, it'll work with all different types of rapid shutdowns. And Sol-Ark is about to come out in December of last year with their own rapid shutdown. So give Kyle a hard time about that. But yes.
Yeah, they've been saying it's going to come out, month after month, and it just keeps getting extended. So hopefully it's sooner than later.
Well, I think as manufacturers that happens, right? Products get delayed and stuff as you're trying to optimize. So,
I mean, one point Nathan brought up before that, just thought I'd touch base on is, again, it's an all-in-one hybrid. So you guys might already know that, but the great thing about that is all the balance of system components, like with the end phase, for example, an AC combiner and relays, automated transfer switches. It's all built into the unit. So you're not going to have to source, more SKUs and things like that with your distributors or direct. It's really all going to be built in the box. Maybe there's 1 or 2 things, on occasion that are needed, but it's really nice to have all that included in the system from the get-go.
Another example of that is yesterday I was showing Rodolfo a picture of, it was 3 6.8s, Schneider. And I shouldn't pick on them because we have closed loop communications with Schneider, but you've got 5 different boxes on your wall when you're installing a Schneider. And what he just said about it all being included in one package, it's all there. The charge controllers are there, the MPPTs are there. You don't have a bunch of independent boxes up on the wall. The whole industry is moving that direction. I kind of wonder why Schneider hasn't come out with the all-in-one inverter yet. Those 6800s are really good inverters, but it's just an inverter, right? And it's not an all-in-one package.
They're just waiting for everybody else to do the research and development, and they'll just copy it.
Yeah. Right.
Yeah, it's
Maybe.
the Chinese way.
Yeah, that's true.
Yeah, I mean, that's the way the Chinese did it, right? I mean, BYD waited until Outback finished the PowerFlex, and then they copied it, even with all its mistakes. It was why, but they were.
Totally agree. And then other points Nathan was bringing up before, once again, the system can be AC coupled or DC coupled. So if you're using microinverters, that's totally okay. You can go that route through AC coupling. DC coupling is pretty much the norm, but you can go either direction.
And you can do both. There's no
Right.
reason you can't have, maybe you go to a job site and they've got 8 kilowatts of AC coupled end phase up on the roof, but they want to add more solar. You could bring that 8K in through the Sol-Ark, but you could simultaneously bring 3 more arrays through the DC side on the Sol-Ark, and you have some AC coupled and some DC coupled.
So, I mean, even if you don't install all Sol-Arks on your jobs, totally understandable, but if the more educated you are with Sol-Ark and, our battery partners, it's going to make a lot of jobs much easier to move forward with.
So I'm going to keep going through the slides with him. One thing I don't know a whole lot about is V2G, vehicle to grid. So if that's your thing, I think you're gonna have to ask him.
It's going to be coming out eventually with the Sol-Ark from electric vehicles to basically use as a power bank, with inverters. So I don't know exactly when on the horizon that's coming. I know like Ford has some options that are kind of coming out and things like that, but it is going to be optional with Sol-Ark, and that's the way I see kind of the future going as well. You have an 80 kilowatt hour, car. That's a pretty perfect backup situation there. So that's pretty
It is
exciting.
until you're stuck at your house.
Yeah, you can't use all of it. That's for sure. Right.
Well, it's the way of the future that not where you're sitting.
No.
Edison will never let it happen.
Yeah, it's going to be a long road ahead with.
Well, if you're a car manufacturer, would you want it to happen? I mean, that's the other thing. How do you warranty? Let's suppose you've got an electric vehicle. How does the manufacturer? Warranties are typically based on mileage. If now somebody's just using the car and power in the house and it's using all the systems of the car, but not putting any mileage, I'm curious how they deal with that.
No,
So-
and flip that backwards. Edison, when you get on an airplane, you shut off your phone because the FAA can't test every phone that walks on the plane, and Edison doesn't want to test every car and prove it as a generator.
Oh, you shut off your phone?
You're supposed to. You're supposed to. Airplane mode. No, but it's the same premise.
Yeah, I get it.
Edison's been testing batteries since the 80s, as y'all know, right? And they just have no desire to test cars. So they're going to fight it.
And that's going to drive more and more off-grid adoption. In the future, it's just going to be more and more off-grid that's happening, and that's where I kind of see the first iterations of that going, with less regulation. Nathan was touching before. DC solar ports. There's 3 full-size MPPTs that have 2 solar ports on each of those. So 6, strings total. I don't know if you consider them strings or not, but
I would, 6 strings.
Yeah.
Yep.
So typically you want those pretty evenly matched with those strings. If you have 20 panels, probably want to do 10 and 10. Per MPPT.
When you're matching solar strings, it's important that the voltages on the end of those match. So each MPPT, you can bring in 2 strings. It's important to match the voltage. It's not important to match the amperage when you're paralleling strings. So, for instance, as long as your voltage of you could go with 200 watt panels and have 5 amps coming out of one string. As long as the voltage of that first string matches the voltage of your second string, you could have, I think I can say 15 because I think those are limited to 20 amps or something. But you could have 15 amps and 5 amps, and that's fine paralleling. You just want to make sure your voltages are similar. Otherwise, you're going to be inefficient.
That's the first 2 ports only, right? And the other 2, you
So
can have them batteries.
you have 2 ports, right? And that's for 1 MPPT. And then the next one, 2 and 2.
The second one, from what I heard, you can go to batteries.
You can go on.
You can balance the voltage. You don't have to have the same voltage for the second MPPT. That's the second set.
Yeah, the MPPT, the first set of panels does not have to match the voltage of the second set of panels. I was just talking about 2 strings combined in a single. Yeah, you have 3 independent inputs, 2 sets of clamps per input. So what I'm talking about is when you use input number 1, match the voltages on your panel that are both going into that input number 1. Yeah. Input number 2, match the voltages that are going into input number 2 if you have 2 strings going there. Okay? And that's because what the MPPT does is it increases the voltage a little bit and sees what happens to the current. So it's constantly increasing, decreasing the voltage to optimize the product of current times voltage, which is power. So that's how it does the power tracking. You need to have panels with similar voltages, otherwise it's not easy for the MPPTs to optimize the power output. But you have 3 independent ones, and number 1 does not have to match 2, 2 doesn't have to match 3. Hopefully that was clear, because I don't feel I've said it clearly, but we can talk about it later too if we need to.
And the other parts will go in more detail, but microgrid controller, really the time of use settings, demand, peak shaving settings, things like that. all programmable, seasonality, programming. California, I think in August, a lot of the times of year, you want to be able to export, during those times. So we'll be able to adjust. And if there's any changes, we'll be able to adjust to whatever those might be.
So what he's saying with that is that the Sol-Ark has the ability to program seasons into it. So you can program the inverter to behave one way, in one fashion during the fall season. And you can set when those seasons start and when they end. I think you have 4, so you could independently program 4 quarters. And I'll talk about that in a little bit. I think I have a slide that's under the basic setup. I think the next one. So I'm going to get into, we've got an hour left, and I do want to pay attention to your time. I did talk to you about these packages before. Obviously, you don't have to follow the package. If you want to use 4 batteries with a Sol-Ark 8K inverter, no problem. Right? If you want to mix and match. This was just to give an idea for homeowners and how much backup time they're going to get. So we talked about this slide a little bit ago about the inverter being the hub of power. It directs power coming into it, power going out to the batteries, power going out to loads, power coming in from batteries, power coming in from a generator. The solar could be AC or DC solar coming in. You've got monitoring and control, which is an important function of the inverter. And of course, disconnecting from that grid for anti-islanding. You don't want the inverter supplying power back onto the grid when somebody's up there working on it. And so the inverter controls all of that. So it manages those power inputs. I do point out here at the beginning that we have load management with our generators, but it's a very different type of load management. Load management with a generator, you don't want to overload the generator. So our load management with our transfer switches and our generators sheds loads based on how much power is being drawn from the generator. So if you've got a 20K generator and you get up to maybe 16K and you can see the generator's getting close to its limit, you might drop off a bigger load. So it incrementally will add loads onto the generator so as not to overload the generator. So that's what our load management looks like with the generators. When we get to inverters, load management looks very different. You will do it potentially based on how much energy is left in your batteries. And if your batteries are draining quickly, you might drop off loads based on that. That's where you use the Span, the Lumen, the Savant panels to do load management. So we talked about disconnecting from the grid. When in a grid down event, this dashed line shows in a partial home backup system with an 8K, a 12K, a 5K Sol-Ark inverter, that you would be isolating just the critical loads panel and no power from the inverter would be going back out to the main panel or the grid. That means the whole main panel would be down in a grid down event, right? You're not backing up the whole home. The 15K really changed that game. I think that with the Powerwall 2, 6.5 kilowatts of power output, something like that. So Sol-Ark came out with this in 2019, maybe late 2018, the 15K with a 200 amp pass through, and now we're truly passing all the power from the grid through the inverter, backing up the entire main panel. So the main panel is off grid in a grid down situation, as opposed to the main panel being connected to the grid but not being powered. Right, that big difference. So here's what a wiring diagram would look like for a managed home backup plan where you've got an essential loads panel that stays live in a grid down event, but the main panel goes down. And I'm mostly giving you this for the wiring diagram. Like I said, I'm going to give you all these slides so you can take this home. We've got recommended wire gauges based on the NEC code, etc. You can change those. You want to make sure you're always following code with them. Depending on cable runs, it might change a little bit. But you essentially have 63 amps of pass-through in the 12K and the 8K inverters. It's the same limitation with the pass-through there. I also point out here that the 120% rule, so who knows where the 120% rule is? Okay, so we don't want to overload our bus bars, right? So we can't, if you've got a 100 amp bus bar, you can't have more than 20 amps backfeeding that bus bar because you can only go 20% over the ratings of the bus bar. Now you could come into that load center and change the bus bars and upgrade those to solar bus bars. But we are not limited in a 100 amp situation to just putting a 20 amp breaker on there as you would be with some other inverters. Why? Right? Does anybody know the acronym? Because I'm kind of blanking on it right now. But the Sol-Ark inverters are they're power control rated, so you can limit the amount of power going back onto bus bars. So if you've got a PCS control, power,
Limit output.
yeah, they limit the output, so you've got that output limitation with the Sol-Ark. So unlike other inverters where you would only be allowed to backfeed 20 amps or 40 amps on a 200 amp panel, that's not, you don't have to limit your breaker to a 40 amp breaker on a 200 amp panel or a 20 amp breaker on a 100 amp panel. Because of the PCS control, the certification, the extra level of certification that Sol-Ark has, right? Because you can limit it inside the Sol-Ark, and they've received that power control system rating, you're not limited on that breaker. Okay, so 15K, similar wiring diagram, but again, now we're going just straight through a fuse disconnect. Now, I don't want to ignore the fact that there are a lot of combo units in California, right? So you might have you've got your service entrance here, but you might have your load center attached to that. What could be your option for that? Well, one of the things you could do is if you have a combo unit, you could feed the Sol-Ark 15K out of two 100 amp breakers on that combo unit, and then you still would have to install another load center. But that allows you to kind of retrofit a combo unit without having to change out your whole service entrance. Okay, and here we're looking at coming out of the controller. Now for a 15K, because they've got dual sets of inputs there, we're recommending coming out of the controller with two 1-aught sets. So you'd have two reds, two blacks coming out, 1-aughts, or 2-aughts. We've actually, in this one here, we put 2-aughts in there. We had it on hand, and those will go into the DC breakers on the Sol-Ark. Then out of the Sol-Ark, we're feeding our power to our main loads panel of the house. If you're using copper, this could be 3-aught instead of 4-aught. If you're using aluminum, that would be a 4-aught connection. And then the communications out of the controller, we have two communications lines. A communication line going to the gateway, and then a communication line going to the Sol-Ark inverter through a dongle. I'll show you in more detail the communications wiring. This was more for the sizing. So we talked about this battery already. I do want to highlight, I mentioned earlier about how NMC chemistry, that's nickel, manganese, cobalt oxide, that NMC chemistry is typically used in batteries that need to be very lightweight. LFP chemistry is a bit heavier. It's about 20% heavier for the same storage size, but it's much safer. And if you're putting batteries in a house, you want it to be safe, you want longer cycle life, that's LFP. You don't want the rapid release of energy in a battery damage situation. So for instance, you've got a contractor there, he's working on the outside of the house, I don't know, shoots a nail or somebody drives the car into the battery, etc. Well, this is just a YouTube channel. This guy reviews batteries. His name is Will Prouse. You probably know him, or you might have seen one of his videos and not even known it. I like Will. He makes really good videos. What he did in this video is he took a pouch cell that was NMC based and drilled a hole in it, and it erupted into, so it smoked for about 3 seconds. I wish I had embedded the video here. Sorry, these are just pictures. But it smoked for about 3 seconds and then it rapidly burst into flame. The cell swelled up like that. I mean, you can see it's a very rapid reaction. He then took a drill and did this with an LFP cell, and he drilled this hole, this hole, this hole, this hole, this hole, a couple more. Wasn't getting it to smoke or catch on fire, and finally drilled another hole and it started smoking. And finally shorted out the inside of the cell. But all it did was smoke, right? And that's the difference. Like the LFP chemistry is a lot safer. You also get more cycles. So So if you're building a drone and it has to be really light, and you want to send the battery up into the air, absolutely, use an NMC cell. If you're putting storage on the side of somebody's house, don't use LFP or NMC chemistry. Use LFP. Okay. So we talked about the limitations of the battery. We can do up to 6 stacks. We can do an individual 1 stack, 2 stacks, 3 stack, a 3 stack and a 2 stack. Don't do a 3 stack and a 1 stack. We don't really recommend that. But otherwise, you can combine them. And then you can do up to 6 stacks. I want to point out that we have all of our existing products. We're still making these batteries here. We still have all of these batteries. Like Rodolfo, or like Brian said, you get the 4.9 battery, this battery on the wall here. It's outdoor rated as well. And it comes with a 15-year warranty. We can build slightly larger systems with this, right? So if you have a really big system, we actually recommend this SimpliPHI non-communicating battery for that, because your batteries can be on a large bus bars, etc. And I'll show you some examples where we've got 100 battery system with Sol-Arks, 7, 8 Sol-Arks paired up. Some villages in Alaska, island in Connecticut. But focusing on the 6.6 here, I also want to point out that you might have used these before. This is our Boss 12 cabinet. You can either put 12 of the 3.8 batteries in this, and then it's a NEMA 3R outdoor rated enclosure. That's this. I've got a Boss 6 in front of me here. This will fit 6 of the 3.8s. And you can get it integrated with, this is an old picture of a Sol-Ark. I need to get that updated. But that's a Sol-Ark 12K. You can get that integrated into the cabinet. We call that the access cabinet. And basically everything comes pre-programmed. We can do the hardened, EMP hardened, right? So you can get everything basically pre-programmed as just a box that you install. And they're really light and easy to install, right? The cabinet, I think, is 600 pounds, so it's just the cabinet, not the batteries, not the inverter in there. But it's really well made, right?
We are working on modifying that to an aluminum enclosure to withstand weather better and also save the water weight.
Yep. So it's heavy, but it's solid and well built. And I've seen enclosures from EG4, which I could bend by pushing on with my thumb. That's not the case. That one's big and heavy, but durable and strong. It's good quality.
And coming up with you can have 15K inside?
We will not be including the 15K inside. And the reason for that is, though the batteries are on a discharge cycle on a battery, it depends on how fast you do it. If you do a very fast discharge cycle on a battery, you might lose 3 or 4% efficiency. If you do, that's not a lot of energy, right? So if you imagine, like on a typical cycle with a battery, you might only generate 1% of heat as loss. So the lithium batteries are very efficient, which means they don't generate a lot of heat. But the Sol-Ark, I mean, it's efficient for an inverter, but it's still, you're looking at about 5% loss when you're bringing power in. So if I bring solar in, I generate 5% of that 10 kilowatts of solar is going to be heat, right? Well, 5% of 10 kilowatts, 500 watts of heat inside an enclosure. We, with the enclosure, have to get rid of that heat, right? So if I put a 15K, which is capable of bringing 35 kilowatts of solar, close to 40 kilowatts of solar in, how do I get all that heat out of the cabinet? The fans on the cabinet simply are not big enough to allow for processing all the heat that a 15K will generate. So I know you are not the only one. This guy here constantly wants us to get the 15K in the cabinet.
Guess what we were just talking about?
We've got installers that want the 15K in the access cabinet because it's really nice plug-and-play solution. But it's difficult from an engineering perspective without designing a cabinet specifically for the 15K. And the 15K is already outdoor rated. So just install the inverter on the wall. I know it's not plug-and-play that way, but
it's nice to have one.
I know. Well, maybe we do come out with a cabinet for the 15K. Right now, we've kind of come out with a battery for the 15K. And we'll see if that's something
Just start selling more of the louvers with gaskets.
It's what we need is bigger fans and a slightly bigger cabinet to accommodate this Sol-Ark 15K. The other limitation on these cabinets is, if you do an access cabinet, you're looking at 23 kilowatt hours of storage. for a 15K inverter, which is capable of burning through it in a couple hours. So it's not quite enough storage. It's you know, ideally we could fit 8 batteries in a 15K and in a 15K cabinet. So no, unfortunately, we're not gonna integrate a 15K into the Access.
Yeah. On a side note, if you guys are familiar with the Access cabinet in the Boss 12 and the Boss 6, it does have that 5-point terminal block in there. We are going to bump that up to a 8-point terminal. So what that means is we can bring an additional cabinet without a combiner to, like say that Access right there. You could put a Boss 12 next to it, wire up each shelf into your 8-point terminal, and then bring a single run over to that Access cabinet that's also going to have a 8-point terminal block in there. And we've got more room in there to bring extra capacity without having a DC combiner.
That's nice. So yeah, so what he's saying is, you know, having a Boss 12 and then having an Access cabinet, you could bring that extra amount of storage in, so you can expand your storage without having to, you know, go.
You can do it now, of course, but you'd have a combiner.
You'd have to buy a combiner. So without having a combiner.
Are you using both 12 and 50K only?
Yeah, sure.
And because
Yeah.
you have like people don't like to see it, they don't have anything with the locked up the system and this kind of things, and we have the Sol-Arks exposed.
Yeah.
You're gonna have it disappear in boxes. So if you take a box 12 and put it in 15K, and we have a battery in another one.
I don't know. I don't know the answer to that. I guess we would have to ask.
Because we have more space inside.
You have more space inside. I still have the questions about thermal management. You know, whether we upgrade fans or. I get it. People want it to be hidden away.
Yeah.
But it's the more power you put into the cabinet, the more heat you have to move out of the cabinet. And so far, I don't have a good solution for you for hiding the 15. It's pretty.
I know.
I get it. So and these are the cabinets just with the batteries. That's the amount of storage you can put in those cabinets. My podium is the smaller one, and the larger one's over there. Okay, so I was going to talk a little bit about just the specs on the 15K right now. So it's a 15K inverter. That means it's capable of turning 15 kilowatts of DC electricity into 15 kilowatts of AC electricity, or approximately. There might be a little bit of losses. But it's only capable of turning 12 kilowatts from batteries into AC power, right? So if you want the full 15K, that's with solar on there as well, right? So it's capable of inverting 15 kilowatts of power. It will bring in, now we said 250 max DC input. I believe it's 275, but that might be on 275 amps would be with a lead acid battery bank. The limitation is the power, not necessarily the current. So you could, if you had a lower voltage battery, you can bring in more power. I'll give you an example. The home grid battery, instead of having 16 cells in series, has 15 cells in series. So the home grid battery actually operates at about 3.2 volts lower than our battery, which means you need more current out of that battery for the same amount of power. Power is current times voltage. So if I reduce the voltage, I have to get more current. So the limitation on the 15K is actually 275 amps, but with a 48 volt battery, it'll pull 250 amps. Our battery is capable of 272, so like I said, it's more than enough to supply the power for Sol-Ark. Also, you can do split phase, you can do single phase, you can do two-phase 208, or with more inverters, you can do three-phase 208. It's only Y configuration. You can't do delta with multiple inverters. But you can do delta if you just create Y and use a transformer to transform back to delta. So, and you can even do, is anybody doing any of that anyway? All right, well you can do, if you do the delta, you can actually do delta with a wild leg as well with a transformer. So basically you can do just about any of it. You can bring in 19.2 kilowatts through the generator port, so you've got a 100 amp breaker there. And then the solar, you can bring 19.5 kilowatts of DC solar in through 3 independent MPPTs. Okay.
Wait, so let's say on the generators also for AC pumping, one of the advantages is it's very easy for retrofit. Somebody that already has a solar array and wants to add batteries, you can use AC pumping and add batteries to the existing solar system.
Okay, so Sol-Ark, Sol-Ark was using PV Pro as their software, and they bought the software, they bought the code, and now are housing all data on US-based servers. And what's really exciting about this, so I'm talking to Liam pretty often, he's the product manager. They also have developed, actually I'm not sure, yeah, I'm not sure how much I'm supposed to say, but they're moving very quickly on their software right now. And that's great because it's going to open even more exciting features, both with utility response, vehicle to grid, and other things. So Sol-Ark is now kind of fully running. The app has turned to My Sol-Ark, and most of you, if you have Sol-Ark systems out there, have probably already been ported over to the new system. So they're running their own software and management. This is an example of what you would see in Sol-Ark software. There are lots of different views. You can view day, you can view different, there are lots of configurations for this. You can view a lot of information about our battery there. So the communicating battery communicates information to the Sol-Ark. And I think I have a slide that'll show you some of what gets displayed. So now to point out here, you've got load that you're looking at throughout the day. You've got DC PV, AC PV here will show up as microinverter. But you've got PV coming throughout the day. You'll see the battery goes negative here. That means the battery's in a state of charge when it's negative. There are times when the battery goes positive. It looks like there are a few times where you've got big loads that kick on and draw some power out of the battery. But for the most part, during the day when that solar is there, it's more than enough for the loads, and that means the battery's in a state of charge. So the solar is at green. Whenever it's above the orange line, that means you're either sending power to the battery and the battery's charging, or you're sending excess power back out to the grid if you have an interconnection agreement. And then what you can see is that solar trails off during the daytime. The battery picks up here to cover those loads during the evening and nighttime. And then the cycle repeats. It looks like this is a fairly small battery bank because they seem to have used all that power by 8 p.m. Right?
Use probably scenario.
And it could be, yeah, time of use scenario as well. Yep. I point out again that I said this in the last talk, but Sol-Ark has free training on their website, so they have the Power Academy, and you can do a lot of their courses online. All of it's free. All of their training is free. And they also run some on-demand webinars. We run on-demand webinars. We do NABCEP certification. You're supposed to get NABCEP certification for today's training that I'm doing right now, but I don't have the certificate yet. I don't have the approval yet from NABCEP. So how many of you are NABCEP certified installers? So your company is. So about half of you. So NABCEP is a National Association of Board Certified Energy Providers, and it's worth getting certified, and there are a lot of companies like ours that'll run free trainings. Other companies charge for the trainings, so you can either pay for trainings or you can come to Sol-Arks and our trainings and get some of them for free to get registered. So I have this slide. This is actually an install I did. My boss was looking at this slide deck. She's like, "What the hell is that?" So this is an install I did in West Africa. This is a village, so you see some huts there. The only reason I'm showing this picture is to get you to start thinking and describing batteries to homeowners like a water storage tank, right? So if you think about this solar array that's up here is running a pump controller, and that's pumping water from a lake up to this elevated water tank that's on that platform up there. And so during the daytime, the water runs into that tank and builds up, and then the village uses it, and throughout the night that water level goes down as people come and fetch water out of it, or the water runs to their couple of plumbing locations that goes to. But you can think of that as a lot like a battery, right? The water represents the energy in the battery, and the flow of water out of that, like a tap is open, the flow of water out of that represents power. So how many gallons per minute are you using? So if you open a lot of valves, you turn on a lot of loads in your house, you can drain a battery really quickly. You can empty the water tank really quickly. So I often describe energy in a system as like water, and power flowing through this system as the number of liters per minute flowing through pipes. Well, just like if I tried to fill this water tank in 60 seconds, I would burst the pipes because there's no way I could put enough pressure on that water to get the flow fast enough to fill the tank that fast, right? Well, same with electricity. What happens when you try to run too much current through a wire, right? It melts, right? It's the same kind of thing. And so the reason I say this is, it's kind of important as we're installers to think about there are limitations on the amount of power a battery has. Everybody knows there's a capacity of a battery to hold a certain amount of energy, right? But if you try to drain that energy too fast, that's power. If you try to pull that energy out too fast, you can damage the battery. And so there are limitations. So I can't take a single one of these 6.6s and run a 15K full bore out of it. The battery will communicate with the inverter and tell it not to anyway. But you have to size your system appropriately. That means you have to size your system not just for how long the outage you want to survive is, but also what's the maximum amount of power you're going to pull out at one moment, right? So if I'm doing, let's say I'm paralleling 3 Sol-Ark 12Ks, right? I'll be drawing a maximum of 9 kilowatts out of each 12K, right, from batteries. So that means that 27 kilowatts of power from these batteries, I need at least 2 of these to provide that power, right? You want to be able to size your batteries based on the power draw. Similarly, 3 Sol-Ark 15Ks, basically a single one of these stacks is designed to provide the power for a 15K. So when you're sizing your system, just make sure you pay attention to the power limitations of the battery, not just the duration of how long that battery's going to last, okay? So what do we do if we want to install multiple stacks with a Sol-Ark 15K? Well, one of the nice things about a Sol-Ark 15K is it's got the dual inputs. So there are 2 ways to do it with a single battery stack. You can either come out of the single battery stack with a 4-aught cable and come directly into these combiner bars that Briggs makes. Sol-Ark doesn't really want us to do that. The whole reason we have 2 battery inputs is to meet the NEC code, and the NEC code says that if you put the battery cable in more than 24 inches of conduit, you have to use the standard battery chart in the NEC, and then 4-aught doesn't have the ampacity to run a 15K. In truth, Sol-Ark 4-aught cable does have the ampacity to run a 15K, because we're only going to be drawing 250 amps of current, but the NEC doesn't allow you to use the battery cable chart if you're in more than 24 inches of conduit. Okay, so to meet that requirement, we don't recommend using these bus bars unless your battery cable is just in free air. So there are plenty of installs, not so many in the US, but there are plenty of installs where they don't require your battery cables for low voltage batteries to be in conduit. I always put it in conduit because I like the look of it anyway. I think it looks better to have all your cables covered, right? But if you are doing it with exposed cabling, you can use these combiner bars and put them on the Sol-Ark. Otherwise, we just recommend for a single stack, use 2 sets of cable. For a double stack, use the 2 cables. Okay? And that's in the wiring charts as well. Okay, so I promised you I'd show you some pictures where we've got this one, I think is 7 or 8 Sol-Ark 12Ks that are here. And we just recommended using the non-communicating Phi batteries for that. All your batteries are connected on this busing that's here. If you need connections to a bus bar manufacturer, we have some links for you. But this, I think, is maybe 80 or 100 of the Phi batteries powering these 8K inverters. And this is up in a village in Alaska. This one on the right, you see 3 inverters on the outside of the room. There are 4 more 15Ks inside the room. This is in Connecticut, and they've got 80 or more batteries, Phi batteries powering this. So if you're doing a big install, the Phi batteries might be a good option for you. And you can get external monitoring equipment for these, and especially if you're doing an indoor install where you know the temperature is going to be relatively constant. You don't have to worry about the communication of the batteries as much under the circumstances. Okay, so let's talk about wiring the 15K, and feel free to come up here. We'll poke around a little bit later. I did install a plastic cover over this so that nobody can, I mean, I've got live wires in here so that nobody can hurt themselves. But we're going to look at the wiring here, and then if you have any questions about it, we can go through it. Kyle can go through it with you. I can go through it with you. But I'm going to point it out on the screen. On the left side of the 15K is the DC side. The DC busing is right above this. There are two independent 200 amp breakers here for the two independent inputs. Right after these breakers, so these both of these breakers are on the positive battery terminals. So we've got two positive battery terminals, and then I've got battery 1 positive is interrupted here, and battery 2 positive is interrupted there. You only need a single pole breaker for DC, right? You only have to interrupt one part of the loop. But they're combined right after this breaker. Those two bus bars become a common DC bus inside the inverter. Here is where the paralleling communications happen. So remember how I said if you wanted to parallel 3, 4, 5 Sol-Ark 15Ks, you would have closed loop. So inverter 1, so let's suppose I had 2 of these. I'd go out of this one to the second inverter, and then out of the second inverter back into the first one. And now I have closed loop communications between the two inverters. So when they need to supply power, they communicate with each other how much power to supply, and so they're splitting the demand, the load.
Sorry.
Go ahead.
So when you're running in parallel, right?
Mhm.
You're taking your stack into one of your inverters. Talk about that connection to the other. Is it just a loop out for your DC battery?
No, and you want to use common, so you would use a combiner, and you would come out of that combiner into both of the inverters.
Equally. Right.
Equally.
Yeah.
And
So if
equal
you're
battery cable lengths if you can.
So if you're using one of the blocks,
Mhm.
you come in from your battery stacks into the block, and then you're running 2 cables to both.
You have 2 cables out of the blocks to both inverters. If you had 3 inverters, the same.
Yeah.
Yep.
Really helpful.
Sure. Okay, this is kind of the communications bar. I've got a separate slide on that, but that's where rapid shutdown, automatic generators start. I'm blanking on other CTs go in there. That's where all of those connections are made, and I'll break that out in a separate slide. Our battery plugs into this battery CAN bus port here. So, or if you had another company's battery, the same thing. So you bring, that's an RJ45 connection. All of those paralleling and battery CAN bus ports are RJ45. So you bring in our batteries through this blue dongle. It comes with a controller. We ship you everything with a controller that you need to do this setup. So you come, I think our Ethernet cable is only 6 foot long, so you might need to supply your own if you've got the inverter and battery farther away. But you come in to that establishes communication between the battery bank and the inverter. This is what I was talking about with the MPPTs. So those 4 connections on the left, that's in solar input number 1. Then the 4 connections in the middle, that's solar input number 2. And the 4 connections on the right, that's solar input number 3. So if you are putting with these 2, positive and negative of solar string number 1, and positive and negative of solar string number 2 there, you want to match voltages on those first 2. That's part of number 1. Match voltages on number the number 3 and 4 connections, I guess, here in the middle, and then 5 and 6 on the right. Okay. All right, then the generator input comes next. The load and grid inputs are 200 amps, so that's 3/0 copper. The generator input is 100 amp limit, so 100 times 240 volts, that's 24 kilowatt max. Really, it's 19 kilowatts of continuous use. So it's derated to about 80 amps of continuous power if you're pulling straight out of the generator continuously. If you have any strength within Sol-Ark, I would get you to have them switch the ground bar and the neutral bar. Yeah, because anyway, it is a little tight to get your neutral connections down here at the bottom. Otherwise, you've got a lot of space compared to other inverters. But you'll notice if once you wire one of these, getting the 3/0 connections, the neutral bent up and in at the bottom is a bit challenging. Tight fit, but the grounding wire is a little bit smaller, so it's easier to bend. So that's my only recommendation.
Is solution for that is moving down into your knockout, to follow down. And
I think that's fine. I don't think Sol-Ark has any problems with you putting your own knockout closer to the neutral bar.
Yeah, but if you have instead for have it already paid down, should it and move into little so much in. You can
Just
still-
tell Kyle, he
you
makes
can
all the
still-
decisions
Yeah,
there.
you can still conduct to the regular grid and not the.
I agree with you. I think either it would be nice to have the knockout farther back, or to have the neutral bar farther up. But otherwise, it's relatively straightforward to wire and pretty easy to wire the 15K. I'll just point out that you've got a load. I've got it labeled as a breaker here. Sorry, that's a typo. It's not a breaker. It's a disconnect. Right? That is not a breaker. It's a 200 amp disconnect, so I can turn my loads off. Why aren't my loads off? Did I turn my load off? Oh, yeah. Thank you. I forgot I demoed that. So I can turn my load off here, but it's not a breaker. So you still want to have a panel. Your panel should have a 200 amp breaker built into it, right? You have to have an in-feed breaker in your panel. And I point that out because you can get panels without it. In fact, I bought this panel without it just because of the size. So then I'm backfeeding a 200 amp breaker to the bus bars here. But you do want to make sure that your load panel your load center has a breaker. Okay, let's see. And that'll come back on in another 60 seconds or something. It has to qualify. Okay, so I promised you I'd break out the pins here on your connections. So, and remember, I'm going to give you all these slides, so I'm happy to share this with you. So the pin out that's here, you've got a number of things. Number 1 and 2, if you do have a lead acid battery bank, the voltage of a lead acid battery bank varies with temperature, the state of charge. So there's a temperature compensation for lead acid battery bank. So you have to monitor the temperature more closely, and pins 1 and 2 allow you to do that. You don't have to do that with lithium batteries, and you definitely don't have to do that with communicating batteries. The voltage state of charge curve with temperature for lithium batteries doesn't really change much. There's not a whole lot of variation between the voltage for a lithium battery as the temperature changes. But pins 3 and 4, those are where your CTs will go, CT number 1, and then 5 and 6 for CT number 2. That would be your leg 1 and your leg 2 coming from utility. Then pins 7 and 8, if you're integrating a generator and you want the inverter to be able to automatically start up the generator when the battery runs low, that's where you would use pins 7 and 8. That's your generator auto start. So that's a really nice feature. If you're using one of our Briggs Stratton generators, you disable auto main sensing in the controls. I think I have a slide coming up on that. And then you would let the Sol-Ark control the start stop of the generator. Pins, the ones labeled BB here, what I would call 11 and 12, that's where the rapid shutdown, that button that I have up there is. And so that's what is required by fire code, that you have a rapid shutdown. And that should be accessible on the outside of the house, right? Then pins 15 and 16, this is your power supply for your rapid shutdown transmitter. So somebody asked me about rapid shutdowns earlier. So it is limited to 100 milliamps maximum. So the only one that I know that will you can power off of that is the AP Smart, or AP Systems, AP Smart rapid shutdowns. But with the Tygo, you would just, you would run your power supply off the load center, and then anytime the loads are on, the solar is on. All right, so connections, you saw the wiring bay on the battery. It's pretty simple. You run one communication wire, this black one here. That'll run to the Sol-Ark through this blue dongle. And the one on the left is the RS485. That'll run to the Briggs Stratton gateway. If you're using, let's suppose you weren't using a Sol-Ark, you were using some other inverter that we maybe don't support, we don't have closed loop communication with, and you wanted to use maybe an Outback inverter, although we're working on that. You wanted to use an Outback inverter that doesn't have closed loop with the same battery, you can do that. You just would use that terminating resistor in the battery, right, to tell it there's no connection to the inverter here. So we put a terminating resistor, and then we would bring the CAN bus into the gateway. Okay, and then if you're using a different set of batteries, like our SimpliPHI battery, the communications would look quite similar. We would just come out of the device port on one of the batteries, and that will come into the Sol-Ark on the battery CAN bus for the Sol-Ark. This is a wiring diagram, too small for you to read right now, I think. But there are kind of two options to bring a generator into a Sol-Ark 15K. One is to just bring it in through the gen port. Another is you've got a 15K on a home already. It's already backing up, sorry, you've got a big generator like a Briggs 26K already backing up the whole home already. It's on a transfer switch. It's got an automatic transfer switch on there. You could take that automatic transfer switch off the wall and wire it in through the gen port on the Sol-Ark 15K. But you could also just leave that transfer switch on the wall and allow come from the transfer switch into the grid port on the inverter. And the inverter is smart enough to know the difference between when the generator is powering it and when the grid is powering it. And the reason it knows that difference is, like I told you earlier, a generator has less stable voltage than the grid. The generator's voltage can vary up and down a little bit. So these are the two wiring diagrams for that. Right here I'm showing you a generator being brought in through the gen port on the inverter. If you do it this way, you're limited to 80 amps continuous from the generator. So 80 amps is 19 kilowatts. I mean, that's enough for most houses. But let's suppose you've got a 26K generator and it's on that transfer switch and you want to be able to pull, or maybe you have a bigger generator than that. Maybe you have a 35K, right? You want to be able to pull all the power off the generator. Just bring it in through the transfer switch to the, you can bring the generator in through the transfer switch to the inverter on the grid port. Now you've got 200 amps that can come off your generator instead of just 80. So like I said, 80 amps is 19 kilowatts continuous power. It can surge up to 100 amps. Probably big enough for most generators, but if you've got a really big generator and you want to be able to pull 200 amps out of your generator or 160 amps out of your generator, leave the transfer switch in. The inverter will not backfeed and ruin your generator. Okay, so one more time, integrating a generator, we can come through the gen port or we can come through a transfer switch and come into the grid port. Got both. That's the pin out again. So let me just show you, if you are doing the 2-wire start, so remember 2-wire start here is pins 7 and 8. So these pins are normally open. It's a dry contactor, meaning you just basically have the pins and they're not touching each other. And when the inverter wants to start up the generator, it connects those two pins inside. It's just a little switch inside that does that. Well, the generator itself has a 12-volt signal, at least on the Briggs generators, has a 12-volt signal, and whenever these two pins are shorted out, it'll start the generator up. Okay? So we bring those in to pins 4 and 5 in our Briggs and Stratton generators, and then anytime the Sol-Ark closes that connection, closes the dry contactor, it'll start up the generator. The generator will start. The Sol-Ark 15K will qualify the signal. Its default, I think, is 60 seconds. And then it'll start passing the generator power into, to charge up the batteries and to power loads. It will only do that when the grid is down. So it won't do that if utility power is there. You can't run the generator at the same time and connect to you cannot parallel the generator to the grid, right? So you can only do that either in an off-grid situation or if the grid port's inactive. This is a little explanation based on time. I think I've got about 20 minutes left. I'm not going to go through how to do this, but basically you just go into this controller. It tells you how to do it here, and you would disable auto main sensing and enable 2-wire start. That lets the Sol-Ark control the Briggs generator. The other thing that you have the ability to do, and we're going to get into this a little bit on the charge, the ways to set up charge. So this column corresponds to generator charging, and this column on settings corresponds to grid charging. You can limit how much power you want to pull off the generator. So if I want to charge my batteries off of a generator, but I've only got maybe a 13K generator, and I think the house might consume, say, 5K, I can limit how much current I'm gonna pull for the battery charging. Keep in mind, this is DC current, so 40 amps times 50 volts, that's only 2,000 watts, right? So a lot of installers think, especially generators installers think, that this is 40 amps at 240 volts, right? So that would be like 9 kilowatts. Sol-Ark needs to label this column amps DC. But it's DC amperage. It's amperage from the battery's perspective. Remember, we're controlling the charging rate of the battery. Okay, so we can control how much charge is going in from the generator. If you check this generator box and then click on OK, this column will be white. It allows you to change the settings. If it's grayed out, it means you can't use it. Sol-Ark, it's checked here, but it's still grayed out, and that's because we haven't clicked OK yet. Or whoever took the picture hasn't clicked OK yet. All right, so keep in mind, Sol-Ark doesn't save any of your changes unless you click OK. So you get people that have made changes and say, no, I changed it, still didn't do anything. It's like, did you click OK? That's save. That's OK means save for Sol-Ark. Okay, another cool thing about the Sol-Ark is, like I told you, you have the ability to change a lot of settings in the Sol-Ark. So you can limit how much power is going out to the load from the Sol-Ark. You might want to limit how much power is coming from the batteries. You can limit how much power you're drawing in on the gen port. So let's suppose I've got a portable generator. I've got just maybe a little 5K portable generator, and I want to bring it into the 15K inverter, which is capable of drawing 100 amps out of it. We can limit how much power the Sol-Ark will allow to be coming out of the generator port. And then if I go over that amount of power and batteries we're charging, it'll slow down the battery charging rate. Or if it's way more power than the generator can supply, it will start discharging the batteries to supply the extra power that's needed. So under the basic setup, advanced tab of the basic setup, you can limit how much power it will pull from the generator, and that way you can use a really small generator through this big port, right? And that's how you can integrate a $500, $1,000 portable into one of these systems. Okay, under the battery setup, so there's not a whole lot to battery setup for us, but I do want to point out one or two common things about the battery. So as we go to the battery setup, first thing, I learned this firsthand, if you do not check this BMS lithium battery box and then click OK, when you first set up your batteries will never output a voltage, okay? So until you click BMS lithium battery, click on OK, the controller is going to flash at you because the Sol-Ark is causing problems with the communication. Okay? So the first thing you do when you go to set up or work on setup for your system is to come into the battery setup tab and check the BMS lithium battery. That way it knows you've got a communicating battery hooked to it. As soon as you do that and click OK, the batteries will start outputting 48 volts and the system will function properly. The default is 00, that's the address for the CAN bus communications. And if you check this activate battery, it allows the inverter to turn on the battery and turn off the battery by itself. All right, this capacity and max charge rate and max discharge rate allows you to set a global limit. Now, the battery itself will set its own limit. The capacity should automatically be filled out here. But whatever limit you set here, the max charge rate, if the battery is requesting a different charge rate, it will take whatever the minimum is. So for instance, there might be some reason that you want to limit the overall rate at which your batteries charge. The batteries have a default rate that's built into them, which is, I think, a 0.7 C rate. If you limit it more here, it will take the smaller value of the two. And the same on the discharge rate. So the batteries are capable of doing up to 272 amps. And the batteries are going to be sending to the inverter, discharge me at 272 amps, but if you put a lower value in here, it will take the lower of the two values. So you can override the batteries if you want to. And that's how you do it with the charge and discharge rate here. Either, if you check battery voltage here, it will display all your values and your set points in terms of voltage of the battery. You can only check voltage or percent. If you use percent, then it will display all the values as the percentage state of charge. So for instance, 51.2 is the voltage at which this battery is half charged at a 50% state of charge. If I have used battery voltage here, it would display my settings in voltages. It used to be we would program them based on voltages. If you use percentage, it will show you everything in percent. So for instance, grid charge is enabled right here. The voltage box was checked here, and so you can see that the voltage is what's displayed here and the percentage is grayed out. If I had selected the percentage here, then the voltage would be grayed out and the percentage would be displayed. And all of these are grayed out here because we don't have the gen box checked. Okay? And remember, if you're changing a setting, you have to click OK after changing it to get it to save. Other thing, if you just installed a generator 2-wire start and you want to test it, if you check the gen box here and then click OK, it will start up your generator and start a charging cycle. So if you want to test it and you're finishing your build, that's what the gen force is there for. It allows you to force the generator to start to test it out. Okay? Okay, the last step on the programming of the batteries, so the shutdown voltage is the voltage at which, this will probably be a percentage for most installs, especially the communicating batteries, but it's the percentage or voltage at which you want the loads to be turned off. So for instance, let's suppose that you don't want to drain your batteries below 10% state of charge. Then you would put 10% here, and whenever you get down to 10%, and the grid is not there to supply the power, a grid down situation, it will shut loads off when you hit 10%. You can set it to 0% if you want. The low battery setting here, it's just once you reach that percentage, 30%, it's going to send a warning to your phone through the app. It's also going to start beeping at you unless you've disabled the beep. It'll just beep, beep, beep. It's really annoying. Everybody always turns off the beep. But it also lets you know that your battery's almost out, okay? The restart value here is, actually I got this wrong before. So the restart value that is there is the value at which it will start redischarging your batteries if grid is also present. So if you have grid present, you would like the grid to power all the loads until your batteries get above that value. If you're below 40%, let's suppose you're at 35% and grid goes off, it will discharge your batteries. Okay, so that value, the restart is only for when grid is present. It will use grid to power the loads until you get above that 40%. The battery efficiency is default 99%. Like I said, it kind of, in reality, it varies a little bit with how fast you charge or discharge the batteries. So if you're discharging your batteries really quickly, your efficiency is going to be more like 96% or something like that. If you're discharging them slowly, you're going to be at 99% or above. The battery resistance doesn't really matter for communicating batteries, but what that does is, let's suppose you set your shutdown voltage to 47 volts. You're using non-communicating batteries like our PHI. But the inverter's under load, it actually allows the shutdown voltage to go below 47 volts. And that's because you lose some voltage inside the battery due to what we call internal resistance, battery resistance. And so it'll adjust the automatic cutoff to be dynamic based on whether or not the inverter has load. That's a nice feature of the Sol-Ark. You truly can get down to, you're really responding to where your batteries are. Not just a voltage. But with communicating batteries, it does it based on state of charge. Okay, you asked about time of use. This is a lot, isn't it? All at once, so I'm throwing it at you here. Time of use, so if you go under grid setup, this will actually have a kind of a divider line between it. It says grid or limit setup, I think. It's been a little while since I turned this on. So it says limiter/grid setup. So it's a slightly old slide here. But what this does is it allows you to limit power to the house, sell back to the grid, control the maximum amount that you sell back to the grid, use time of use, set time of use windows here, control how much power during each different window that you're willing to use from the grid. You can even limit power to load, limit the amount of power you're pulling from the grid going to load, so that you supplement that with batteries, so you never draw more than a certain amount to your house. You can zero it out so that your house doesn't use anything from the grid. And so there are a lot of options here, and Kyle can talk more with you about how to set that up. But you can do it based on battery percentages and power differences at different times of the day, so that when electricity is expensive, you don't draw from the grid, you use the batteries, right?
And if it's your first time commissioning one of the systems, I highly recommend just giving me a call. I'll hook you up with one of our field applications engineers, walk you through it. On our website too, we have a full rundown of how to program these specifically for California time review settings.
We have, so I'm about done, so we've got just a few minutes left. So if you're tired of my voice, my apologies. We have some trainings online to talk you through this, but this is the Energy Track app from Briggs, so you can get this on your phone, your tablet. I also have it on my laptop, but it allows you to monitor each individual battery. So I've got 3 batteries there. What we send to Sol-Ark is the whole package, like what the average temperature of all the batteries is. But what this allows me to do is break out the individual batteries, any information about the individual batteries, and our tech support team can see that remotely as well. So we might even send you a warning before you even know that you have a problem, to just let you know, hey, this is happening, etc. Sol-Ark's app, this is all battery information here that our batteries are transmitting to the Sol-Ark, and you can get information about battery capacity, battery temperature, battery voltage, charging voltage, discharging voltage, limits on the amperage, the battery overall, this is the average temperature, current amount of power coming from the battery, so it's only using 20 watts there, state of charge, lots of information here that we do send to Sol-Ark, and Sol-Ark displays, and maybe in the future we'll give individual battery level monitoring to Sol-Ark as well. We don't currently have that yet, but I know Liam, the project manager for the low voltage inverters, wants us to integrate that. And then I'm sorry, I meant to change the slide title. It's not called PV Pro anymore, it's called My Sol-Ark, the app for monitoring. And it gives you views like this. We went through a couple examples earlier, so I'm not going to talk through these just based on time. And the last thing I wanted to talk to you about is lithium batteries. So all lithium batteries currently, solid state batteries might not have this problem, but they have other problems, have the challenge that when in cold temperatures, when the battery is charging, what's happening is the lithium is moving from the cathode layer. In the case of our batteries, that's the LFP, the iron phosphate, over into the graphite layer, which is the anode, the negative terminal of the battery. When lithium is doing that in cold temperatures, what can happen is the lithium can get stuck on the outside of the graphite layers. So in microscopic scales, what's happening when atoms and molecules are really cold is they get pretty rigid. They're not moving around much. And so if you have graphite and it's kind of cold temperature, it's quite rigid, and the molecules are not able to slip in place very easily, and the electrolyte is also much more viscous. What happens is you can get lithium that builds up on the outside of that graphite, and that's called lithiation. You might have heard the term dendrite. Dendrite means I think just branches. And what can happen is the lithium can actually grow with time. And so if you charge your batteries really rapidly at low temperature, it can reduce your cycle life of your battery or even ruin your battery over time. That's why most manufacturers just turn off charging below 32 degrees Fahrenheit. But we've got a more innovative way to do that with our batteries. And so what we do is we slow down the charging rate at low temperatures. And so unlike other batteries, which would just cut off charging down in this window between -4 and -7, we slow it down. And so we send different rates of charging to the Sol-Ark based on what the temperature is. And that allows us to keep our batteries healthy. It allows us to charge our batteries early in the morning when they're still cold. And it allows us to even heat the batteries a little bit with the resistive heating that's happening. So whenever you're charging batteries when they're cold, they're a lot less efficient. They're much more viscous. And so the movement of lithium through the batteries when they're charging up produces more heat. That heats the cell up. And then gradually as the cell heats up, we can charge it faster. And so what we do is we send different rates through, and by the time we get up to 7 degrees Celsius, we're charging pretty quickly, and then we're charging at a full rate between 7 and 50 Celsius. So anyway, we have that ability to do that because we have closed loop communication with the Sol-Ark, and we can tell the Sol-Ark what rate do you charge our batteries at. We also have battery heaters that we can integrate into batteries that are manufactured here in Oxnard. So we can integrate this if you are ever doing a project in really low temperature and you want to integrate a battery heater that will use, I think it's a 75 watt heater, and it turns on and off based on the internal battery temperature. So for cold environments, like I think I'm going to show you a picture. This is Buffalo, New York. Did you see this, John? So yeah, so this install has looks like 6 Sol-Ark 15Ks. 4 Boss 12 cabinets, a couple of these combiners here. Boss 6s. One of them must be. One of them is a combiner because otherwise he should have bought 5 Boss 12. Yeah. Okay. So this is a cold temperature environment in Buffalo, New York. My sister lives there. Don't have family that lives there. You don't want to visit them. But it gets very cold, right, in winter time, and then they get a ton of snow from the lake effect, etc. But we've just got these heated battery options that are there. And we don't have to heat the entire cabinet. We heat just the internal part of the battery, which is the only part that matters with these. And that's it. We're done. I wish I could offer you NABCEP credit for this if you wanted it, but unfortunately I didn't get that paperwork back yet from them. I can offer you $1,000 off your first system that you install. So talk to Brian or Rodolfo about that. So we do have a bonus. Does it come back as cash, or does it come back as a
check? Yeah.
A check. So you actually get cash from us, and it's more than that because.
1,000 per system plus 100 per battery.
Yeah. So if you are signing up, I encourage you to actually also sign up as one of our elite installers. Because if you join the installer program, every battery module that you install, you get another $100 back on that. So you can talk to Rodolfo how to get your company set up. That also gets you placed on our map, so that when we get leads that come in, the first thing that we do is we just look for an installer that's elite IQ installer in their area, which means they've registered with us. We have plenty of installers that don't, but we look for an installer that's on our map, and then we send them your way. So it's a way for us to get leads to you as well if you're interested. So talk to those guys about it. There's that rebate is up there, but he's already put a flyer on your desk of how to get that rebate. So,
That 1,000, that's the first system only, but the 100 per battery, that
continuous.
going, yeah.
That-
After the first system, it keeps going.
Yeah, the $100 per battery we do quarterly. So if you've installed 12 batteries in a quarter, at the end of the quarter, you'll get a check from us for $1,200. So it's worth it. It used to be $25, so it's now much more substantial, right? Getting a check for $600 at the end of the quarter, it's like, that's okay. But getting a check for 4 times that, $2,400 is nice. So thanks. Talk to us. We're done. I'm going to send you the slides. So I have all of your emails on the sign-in page and on the registration. If I didn't get your email for some reason and you want the slides, just come talk to me now. So thank you for your time.